All right, so now let's go ahead and jump into integrating databases into our application. And we're going to start or continue on essentially where we left off, which is going to be in our Docker Compose file. Now, by now, I do expect some sort of SQL familiarity, just, being able to write some SQL statements, understanding a table structure and schema. It's really, yeah, we're kind of going to assume that knowledge, and it's, yeah, obviously going to help you a lot going forward knowing this. So yeah, if you've taken my SQL course, you should be fine. If you haven't, now would be a great time to take it, and then come back to that once you've done this. But yeah, in this lesson, we're just going to focus on the Docker Compose part, which is just going to be kind of getting our Postgres database up and running. All right, so we're going to go in here and we're going to add another service. And here we're going to add our Postgres database. So I'm going to call this service our Postgres DB, but you can call it whatever. A very common name, for example, is also DB, keeps it short and simple. But I'm going to call it Postgres DB because, well, I like it. It's a little bit more descriptive, but honestly, it's up to you. All right, so instead of using some build and context like we have here where we've specified Docker files, instead we're going to pull directly a Postgres image. Now if you look on Docker Hub, well, by the time you're seeing this, there may be later versions, but currently the latest one is going to be 14.1, which is the one that we're going to use, and again we're going to pull the Alpine image. So I'm going to specify a specific image, which is going to be the official Postgres image, version 14.1, or whoops, using the Alpine tag like this. All right, so this is going to be our Postgres database, and it's going to pull from here. Now there are several other things that we need to add. The first thing that I'm going to add for now is just going to be our port mapping like we have here, so that we can also access it from outside of the container. So I'm going to do that using our ports, and I'm going to find the mapping here 5432, 5432. So 5432 is kind of the default Postgres port. So I'm going to keep it as that and not really mess with that, just because, again, it's kind of the default one. All right, so the next thing that we need, well, two things, both of which we haven't seen yet, at least not in Docker Compose. The first one is going to be environment variables. So we're going to define that using environment. And then I'm going to provide my variables here as a list. And the first one is going to be our Postgres user, which we're going to assign to just Postgres right now. So that's going to be the username that we're going to log in with. The next one is going to be the password. And that one we're going to set using Postgres password like this, which again, I'm going to keep simple and just set to Postgres. Now this third one is optional. If you don't set it, it's going to be the same as the user, but I'm going to set it just to be explicit, which is going to be our Postgres DB, which is going to be the default database that's going to be created. And I'm also going to use this Postgres. So everything is Postgres because obviously this isn't going into production. This is just something that we're going to use locally to do testing, and I'm just going to keep it simple and reuse the same thing. All right, so these are our environment variables. And finally, we want to use a volume. Now we've talked about volumes previously and we've kind of used them here, but now we're actually going to use a separate volume which is going to take care of storing and persisting our data, and we'll really see volumes in action again in just a second. So we're going to use the same thing. We're going to define our volumes, and well, I'll create this volume in a second, but I'm going to call our volume PGDB. Could also call it like PG data or DB or whatever you want. I'm going to call it PGDB, and I'm going to define it down here in a second too. And this is going to map to this specific location, PostgreSQL, which is important that we're mapping to this location because that's where our data is going to be stored. So this is the volume that we're mapping to this location in our container. All right, and now we're going to define our volumes down here. Notice we have services, and these are all the services we have defined. And now we're actually going to define a volume here too. And I'm going to define this PGDB, which is going to be this one here. And I'm just going to leave this empty. I'm not going to add anything extra here. There are extra options that you can add if you want to, but we really don't need any because we just need this for our local testing. As a quick aside, if you haven't changed this back, it's not really happening in a Docker Compose, but just remember if you're in other files that we changed the spacing here. So just kind of as a quick aside, if you haven't changed that back, just keep that in mind in case things get a little weird. Okay, so anyway, what did we do? So we've created a new service, which we've called PostgreSDB. This here pulls this version here, the official Postgres image with the tag 14.1-alpine. We're going to open up port 5432, which is going to map to port 5432 in our container. We're going to provide these environment variables, and we're also going to map a persistent volume to it that Docker is going to manage for us, which is going to allow us to persist data across starting up and tearing down our service here. And we'll see that in action in a second. All right, so let's go ahead and spin this up. I'm going to do Docker Compose up -d to run it as a daemon process. If you're running this for the first time, then it's going to take a little bit of time because this image needs to get pulled. If you've run this before already, then, well, it's going to be fine. Oh, actually, I already have something running, so I'm going to take this down first and then spin it up one more time. And all right, there we go. Okay. So before we get into any of the kind of coding integration, let's just have a visual component first. And so I'm going to use the data grip tool, which is also something that I've used in my SQL course. So I'm going to just open that up. The data grip tool is extremely nice. I love it. It does come with a free 30-day trial, but you'll see in a second, my free trial has expired and it still gives you the option to use it. You just kind of have a 30-minute timer on it. But yeah, I'm able to just kind of use it, and then I've never actually hit the 30-minute timer because I don't use databases introspection with data grip that much anymore, but it's still extremely useful. So you can see here, I'm just going to hit OK, and just still be able to use it for local development purposes, which is nice. All right, so let's bring that over onto our screen here. I'm going to add a data source. I'm going to add a Postgres database. And let's wait for this to pop up. All right, so our host is going to be our local host. The port is going to be port 5432. Our username and password is Postgres. And Postgres, I think I made a typo here, which is what we set in our environment variables here, and our database is also Postgres. Test connection, just to make sure it's running. It should be running because my Docker container right now is running because I started these up. If these are not running, it should not be running. So make sure that you have these running beforehand. All right, then I'm going to hit apply, OK, and I'm going to wait for it to fill in here. And all right, here we go. So I'm going to go into our public schema. I'm going to create a new temporary test table, and we're just going to use this to kind of look at volumes in action. Bring this over onto our screen too. So I'll call this one our test table. And this here is just going to have a first column test, which is going to be an integer, which will be our primary key. We're going to have a second column test t, which is going to be a test2, which is going to be of type text. So 2 columns. Execute. Let's wait for this table to get created. Not sure why this is taking so long, so I'm actually going to just quit this and open a query console, which we already have here, and just run it in here instead. There we go. All right, excellent. So let's go ahead and refresh this. And there we have our test table that is being created. Okay, great. So let's take a look at our test table. And I'm just going to use the UI here, which is very nice, to insert some data. Click on the plus here, integer, let's have this be 1, and this some test value. This is going to commit it to our database. And then if I hit refresh here, we can see, okay, so we have 1 row in our table. Now let's go back to here and pull this down. So we're taking down all of our containers. Go back to data grip. And if I try to refresh now, we're going to see we have a connection issue. All right, this is expected. We just took this down. So now let's take it back up. Docker compose up -d. And wait for this to start up. All right, refresh again. Great, our data is still here as expected. And now, if we do Docker compose, if we want to remove our data, so what we've just seen is we used a volume, we were able to take down our container, start it back up, our data is still there. If we want our data to be removed, we're going to add the -v flag. This is going to take down our volume. And now we'll see, well, actually we won't see because all of our containers are down. So let's spin things back up. And wait for this to build. And there we go. All right, so if I click refresh here, we're going to enter a problem, but it's not a connection problem. So I'm going to go over here and also refresh this. And now we'll see our table has actually disappeared. So adding that -v flag when we were taking it down essentially kind of reset our volume. So what we've done here is we've created an additional Postgres service, which is now running a Postgres image for us. We've provided it with some default environment configurations. We've provided it here with a persistent volume. That means we can store our data across taking our container up and down, which is obviously really nice, but we've also seen we can use the -v flag when taking it down to actually clear our data. Now this volume is going to be created for us, and so it assumes that it does not exist. Yeah. All right, so this is essentially how we can add our Postgres database into our containers or into our Docker Compose, and with this we'll also now be able to use it in our application, which we'll see in later lessons. Now, one more quick thing I want to show you. We have this environment here where we can set our environment variables. These are specific environment variables that are required by Postgres. They have to have like these naming conventions as well as also the volume mapping that we're using here. So, you know, these are kind of standard ones that Postgres is looking for. But something that we can also do if we want to, instead of putting these environment variables here, we can actually put them into environment file. So I'm going to create a .env-local file, and this is just going to be a plain text file, and it's going to, I'm going to take our environment variables here, and I'm going to post them over here, get rid of this stuff, and show you another way how we can read in environment data. And so I'm going to, instead of using environment, I'm instead going to use the env file here. And here, I'm now going to point to our .env-local file. And now, if I take it down and bring it back up, it should still work properly once this is up and running. All right, so now we should, well, we are connected, but we should still be able to connect to it. Connection failed right now. Let's try that again. And let's try to execute a query against it. So let's do another create table, test table. We're going to have here test integer primary key, and let's do test 1, 2, 3 text. And let's go ahead and execute this and update. And there we go. We have our new test table with the new column. So yeah, as we can see, Docker Compose is amazing. It's extremely easy for us to add extra components there. Volumes are great things too because it allows us to kind of persist data over multiple runs as we spin up and take down containers. We're obviously using local volumes here, but you can also use volumes if you're running things in production because it's a really nice way to kind of persist data, again, because with containers going up and down, you don't want anything on that local container because if it goes down, that data is gone. You want to persist it elsewhere. So yeah, this is how we can go about spinning up our Postgres service, and now it's really nice because we can just integrate this into our application, and it's really nice because we don't have to install anything else. To help with this, we can just super easily access it, and all we had to do was just add it into our Docker Compose here. All right, so previously we've seen how we can add Postgres into our Docker Compose here, and we were able to create a table and everything like that, and also see that using data grip. Now what we're going to do is we're going to learn how we can actually create database models in our Python code here too. So I'm already going to go ahead and just pip-env install, and we're going to use SQL Alchemy, and we're also going to need scicop G2 binary. I always have trouble pronouncing this name here. So go ahead and install both of these. We're going to be installing these not as dev dependencies, so just kind of regular dependencies. And this installation process may take a little bit of time, so that's why we already want to start it now. But yeah, so we're going to learn how we can actually create these models in our database so that when we go, for example, to our table here, we don't actually have to write our SQL code, but rather we have models that we can use in our application that are also Python code, which has a lot of benefits to it. For one, they're like Python objects, which obviously makes it easier for us to use because they're representations of the models that we have in our database. And at the same time, which we'll see later, we'll be much easier able to kind of reproduce creating all of our tables and essentially making sure that if we ever need to change things, all of those things are consistent. Because if you're just writing like SQL code, then really if you're creating and altering tables, you have to keep track of every single change. And that's easy to forget to do that. So we're going to do all this in Python, and it's going to take care of everything for us. All right, so with those libraries installed, the first thing that I'm going to do is I'm just going to create a separate folder here that I'm going to call models, like this. And this here is just going to hold all the models that we're going to define in a second. So I'm going to do several things here. I'm going to create an initialization folder like this. Initialization file. I'm also going to create a base file, which we'll see what that holds in a second. And essentially what we're trying to do right now is if we're going to our user service here, for example, and the schemas. And if we just take a look at the schemas that we have defined here, as well as going into our user service and looking at these objects. Right now we just define them as a dictionary, but okay. Essentially these objects that we've kind of created that have been substitutes for us that aren't really holding much, but they're kind of database substitute objects. So essentially our goal is going to be to obviously remove these because we don't want to hold these like dictionary objects, and instead have some sort of database model. And so for one, we're going to create this user table, which is going to probably hold this information here. And then I'm going to create a second table, which is just actually going to hold this mapping here. So that's going to kind of be like the basis we're going to form. I'm not actually going to create a post table because it will work very similar to the user table. So we're just going to really create the real basis of exactly what we need just to hold this information, so that in our services here, we don't need to use a dictionary for this, but instead, we can actually use like database connections. That's going to be our end goal here. All right, so we have our base file. We'll see what goes in there in a second. Then I'm also going to create a user file. This is going to hold our user model. And I'm also going to create another file here that's going to be the liked post. Yep. And yeah, that's going to hold this, if we go into our schema, this liked posts mapping. All right, so we'll start off with the base because this kind of forms the basis of what we need. And it's essentially just going to be some kind of SQL Alchemy setup. So SQL Alchemy, as a quick kind of aside, is a library that provides us with this. It's called ORM, or short for ORM, which stands for Object Relational Mapper. So essentially we're able to have these Python objects that relate to these relational models that we have here. So essentially we're able to use Python code and Python objects to write SQL. That's kind of what it allows us to do, and it has a lot of nice features that makes all of that extremely easy for us. And so that's why we installed that. Because we're using Postgres, we also needed to install this library here, which just allows us or gives us the Postgres connection. All right, So we're going to start off with the base here, and we're just going to say from sqlalchemy.x.declarative, we're going to import declarative base. This is going to allow us to create a base object that we'll use in a second that has a metadata object associated to it, which keeps track of this table information. And we're also going to say from sqlalchemy, we're going to import, oops, that's not what I want. I want create engine. This create engine, what it will allow us to do is we can create a database engine that we can then use to write commands over. So that's actually going to, help us kind of spawn this, and essentially we're going to use that to, issue commands. And then we want to actually, from our application, we want to import our configuration here. And we're going to change this up in a little bit. But yeah, I'm going to say from app.config, I'm going to import our configuration too. And this is just kind of to, have the configuration be in one place and not redefine things in multiple places. All right, so for the sqlalchemy setup, I'm going to define a base object, and this is just going to call this declarative base function that we have available to us. And essentially, this is then what we're going to use, or the object that we need to inherit from, as we'll see in a second, when we're actually creating our database models, and that will kind of take care of all the, table related stuff in the background. And this is essentially going to, kind of form the backbone of allowing us to do all this very, very easily. And the next thing that we want is we want an initialized version of our configuration. Although in our case, we actually have all these as static variables, but we're just going to initialize it anyway. And this is not where I wanted to go. Here we go. And now we also want to create an engine which we can use later on to issue these commands over. So we're going to create an engine through this create engine function. And here we need to provide the URL of our database. And for that, we're going to use this config that we've created. So for now, I'm going to say config.dbhost. We'll change this up in a little bit though. And then there's one more command that I'm going to add here, which is going to be echo set to true. And we'll turn this off later on, but for now we're going to leave this on because this will actually print out all of the commands that are being run, which is nice because then we get to see them. All right. And we're also going to define another helper function, which we're going to call recreate Postgres tables. And what this is going to do is it's going to take the base object that we've created up here. We're going to access this internal metadata object, and then we're going to call drop all, and we're just going to use the engine that we've created up here. And then what I'm going to do is I'm going to do base.metadata.create all. So essentially what this function does is it's going to drop all tables associated to our base class here. It's going to use this engine for it, and then it's going to create all the tables associated to our base metadata object here that's registered to it. So this is just going to be a small helper function for that purpose. All right, so this right here may seem a little bit, confusing, but don't worry. Now we're going to go ahead and actually start creating the tables, and then you'll see how we're going to use this. And really, again, this kind of just, it has a lot of power hidden inside of it, and we're just going to, use one line to create it, as well as using one line here to create our engine. And it's going to allow us to do a lot of stuff, but you don't necessarily need to, worry about the internal functionalities of it too much, because that's obviously why sqlalchemy exists, to help extract all of that away and essentially allow us to issue SQL commands to our databases without having to worry about all the things of, how that can run in the background. But essentially, that's what each of these two things is responsible for. And obviously, if you're interested in that, you can take a deep dive through the documentation for that, or even just go into these functions by just following them and kind of reading through what they do. But yeah, anyway, obviously we're not going to take a deep dive into that because we want to use this to actually do our stuff. So we're going to start off in our user file here. And what I'm going to do is I'm going to say from models.base, I want to import this base object that we've created. And then I'm going to create our first table. And I'm going to do this using Python class. And I'm going to create our user table. I'm going to inherit from the base object that we've created over here. And now I can start defining columns as well as also table elements. So the first thing I'm going to do is I'm going to assign our table a table name using this parameter. I'm going to call it user, like this, and it's going to match the name of our class. One kind of noteworthy thing to point out here is sometimes you'll see tables written with an S at the end, so it's going to be plurals, or you'll have them be singular. I think people have a lot of discussion about this. At the end of the day, as long as you're consistent, I think that's the most important thing. If you use one convention, if you have everything plural, make sure everything is plural. If you have everything singular, make sure everything is singular. Because there are two ways of looking at it. One, the table holds users, or the table, each row is a user object. So there are two ways of looking at the same thing. And at the end of the day, it really just depends on consistency. Like, that's the most important thing. But we're going to use the singular version here. All right, so we're going to create our first column. Our first column is going to be an ID column, which is going to be our primary key, and it's just going to be an auto-incrementing integer. So to do this, I need to import some helper stuff from SQL Alchemy. So I'm going to say, from SQL Alchemy, I'm going to import the column object as well as the integer. And then I can say, I'm going to create, or this ID is going to be a column, and its type is going to be the integer type that we have here. And to set it as a primary key, I'm going to just provide an extra argument to our column here. I'm going to say that primary key value is true. So this is going to be our primary key here. All right, great. The next thing that we're going to do, or I guess maybe before we move on to the next thing, one quick word here is generally you want to have some sort of unique identification for, especially for like your users or anything that kind of has this unique essence to it. Obviously using IDs is integer, especially when we're doing like walkthroughs and tutorials and stuff. In organizations, I've often seen this instead be strings, and you essentially use a UUID. So, that's the other option that I've seen used a lot. But, personally, when doing like hobby projects and tutorials and stuff like that, I like to use integers because it's just easier. But generally in organizations, I've seen this be, or this has, in my experience, generally always been UUIDs. And that's probably also what you're going to see, once you start working somewhere, is it's very likely that this is going to be a UUID string instead of an integer. Anyway, that aside, the next column that's pretty default to have is some sort of created at column, which is just going to hold some timestamp value. So we still have our column, but now we need to have the proper type. The type that we want here is a timestamp type like this. And we're also going to set a default value for this. Now, you don't need to do this, but I just find this a lot easier because the created at is really the time that this object was created, which we can interpret as the time this object was inserted into the database. And so we can use some really nice functionality, which is we can assign a default value to it. So rather than having to pass this every single time, we're going to assign a default value, and we're going to use the datetime library for this. And we're going to say datetime.datetime.utc now. So we're going into the datetime library, we're going into the datetime object, and here we're using this UTC now method, which just gives us the current date and time in UTC. So this just kind of keeps our time zone consistent, which is really important because time zones can be very frustrating to work with if they're all over the place. So generally I would recommend always just sticking with using UTC time zones, and that way you do not have to worry about possible like time mismatches because one thing is in one time zone and the other thing is another. Just always try to stick to UTC to keep things consistent. Now another important thing here is I purposefully did not call this method, because if we call this method, then our default time is actually going to be the time that this code ran the first time. But if we use it like this, then it's going to be the actual time that we want, which is going to be when it's inserted into the database. So if you call this method, you're going to have a fixed time for all objects created. So make sure to not do that, and keep it like this format. Another common parameter that we're not going to add is like an updated at, which essentially does a similar thing, but rather than keeping track of the created, essentially every time if you want to update this, you also update this updated at parameter so that you know the last time when this object was changed. But again, we're not going to implement this here. Another interesting parameter that we probably want to have is our username. So that's going to be a string value. So we need to import that from here. Now I'm going to give this text here just unbound size, but if you want a limited size to say 5 characters, then you can put that in there like this. But just know that if you try to insert anything larger than this, it's going to fail. So for this purpose, I'm just going to leave it unbound, but obviously you can, put some sort of like upper bound here just to not have it go off too far. Like you could put in like 60, 120, or whatever you feel is reasonable. And most of the time you're going to want to do this in actual databases because it helps with conserving space and actually properly or more properly structuring the space that you're using on disk, kind of keeping that consistent. But for now, I'm just going to leave it, unset, so that essentially this can be any size. Then we're also going to have our short description, and this is just going to be another string column. And we're also going to have our long bio. This is going to be another string column. And that's going to be it for our purposes because that's kind of what we have. However, obviously in a real database, there are probably going to be more columns that you want to add here. So for example, you maybe want to add like an email field that holds the email. You maybe want to have a password field, which does not hold the raw password, but it holds an encrypted version of the password. If you are even, like storing and creating passwords, because some applications will just use authentication from other services, like single sign-on with Google or Facebook or Apple or whatever, those options that you always have. So sometimes you're not even able to create your account there because they don't want to store passwords. But if you do ever have to store a password, make sure you store the encrypted version. And then when you're checking if a password is correct, you encrypt the password that they entered and you check if that encryption result equals what is stored in the database. You do not want to store raw passwords. Very important. But anyway, we're not going to be doing that. So we're just going to leave it like this. So this is going to be our user object. We have our primary key, which is an ID here. We have a created at column that tells us when this object was created. We have a username, a short description, and a long bio. Now, before we move on to our like posts, something that we probably want to do is we want to have this thing here be unique because we don't want multiple people with the same username. So to do that, I'm going to import this unique constraint, and then we're going to set another parameter here, which is going to be table args like this. And we're going to provide here an argument of constraints as a tuple. So the first constraint that we have is going to be our unique constraint. And here we want the username to be unique. And the name that we're going to assign to this constraint is just username unique, like this. And because it has to be a tuple, we're going to put a comma after here, which is going to make this a one tuple. But again, this has to be a tuple. So this kind of format is required. All right, so we've created our first table, which is nice because this is obviously just a Python object that we can also use in our code. And really all that we needed to do this is have this base object that we've inherited from. And that's going to take care of assigning the metadata, which is just going to help SQL Alchemy keep track of all of the properties associated to our table as well as all the tables we have. So it's going to take care of all of that for us. All right, so let's go ahead and do the same thing for our like posts here. Just go through this a little bit quicker since we've already done one. So I'm going to just create a new class, which is going to be the like post. We're going to inherit from base, so we need to import that from models.base. We want to import base. I'm going to create another ID column, which is going to be, so that we need to import too from SQL Alchemy. We want to import column. I also want the integer value as well as the timestamp. And imported the wrong thing here, like this. All right, so our ID is going to be an integer value just like before. It's also going to be our primary key. We want to give this a table name too. Double underscore. It's going to be liked post. The next thing we want is our created at column again, which is going to be a timestamp of value. Again, here we're going to set a default, and we're going to just import date time here and do the exact same thing. Datetime.datetime.utc now, and make sure that we do not call this, but we leave this like this. All right. So now we want two more things here. First, we want the user ID of the user who liked the post. So that's going to be an integer because this is going to reference our primary key here. And we also want the ID of the post that the user liked. So what our liked post table is going to do, or what it's going to be, is it's going to be every single row is going to essentially be a mapping of which user liked which post and when they did this. So that's the information that this is going to hold for us. So some more things that we probably want to add here is we want to make sure that these values are not null. So we're going to set nullable to false like this, because we obviously, we obviously do not want either our user or our post to be a null value. So we want to make sure that the nullable values here are set to false. Another thing that we probably want to add is a unique constraint. And that's going to say that we do not want more than one user post entry. A user cannot like a post more than once. So we're going to add here our table args like this, and again, make this a tuple. We're going to have our unique constraint here. And here what our constraint is going to be is it's going to be the user ID and the post ID. And the name that we're going to give to it is it's going to be user post unique. Or we can say user ID post ID unique. I'll just keep it short. Now another thing that we want is we want some sort of foreign key mapping. So we want to indicate that this user ID maps to a value that is the ID column of this user table. Now this is nice to have for two purposes. One, it's really nice when you're looking at the table as someone who didn't create it and you know that this, like what this value refers to, what user value ID should I be looking at, what table should I be looking at for this. It's really informative for that. The other thing is that it actually it has this inbuilt check that you cannot put in user IDs here that do not exist in this table. So if we only have two users, you can't say user 5 like post 7 if user 5 does not exist, which is also really nice because it helps keep our data clean. So to do that, I'm going to import a foreign key constraint, and I'm also going to put this into our table args here. And I'm going to say our foreign key constraint here is going to be our user ID column here, references, and the user.id table. So this name here is this name here. And this dot indicates that we're now going to look at the column. This column name here is this column name here. All right, we're not going to do the same thing for post because, like I said, I'm not going to create a post table because it'd essentially be repeating this one more time. And, I don't want to make all this drag out too long. There is one more thing that I want to do, though, which is we also would ideally like to create some sort of index maybe. Maybe we want to create an index on our user. So what the index allows us to do is the database will actually keep track of specific ways of looking at data. And so if we want to search for things by users, which is what we'll very often do, as well as also searching by things by post, then if we don't have an index, it's going to have to go through the whole database. But if we have an index on our user ID and we say we want to look for a specific user, it already kept track of what rows are associated with each user and will actually point us to those. So indexes can make our queries a lot more efficient if we are searching or grouping along those indices. So we're going to create an index. We're going to call it liked post user ID IDX for index, and the column here is going to be the liked post, and then we're going to use .c to access the column value, and then we're going to have this user ID. So we're going to say this index here is an index on the user ID column in this liked post table that we have just above right here. All right, so yeah, now what we want to do is we want to make sure that all of this stuff gets properly registered. So what I'm going to do is I'm going to go into the initialization here. I'm going to say from models.base, I'm going to import this base. I'm going to say from models dot, oh, 1 second, we'll open that up back up in a second. From models dot users, we're going to import user, and from models dot like post, we're going to import like post, and that's going to be it. And so all that this is going to do is it's going to import this base here, which also gives us easier access, which we'll see in a second. It's going to import this user object here, and it's going to import this like post. And essentially by importing this, whenever we are going into this package that we've created here, we are registering, or we're going to be defining these functions, which is nice because that means we'll actually add it to our base object. Because otherwise, we would need to import our models to actually make sure they're registered. And obviously, we probably don't want to do that, but rather, when we want to create our databases, as we'll see in a second, we just want to be able to do that all at once and not have to import everything first. So yeah, one more thing I'm going to import here is going to be this helper function that we've created, recreate Postgres tables. All right, so this is kind of everything about our models. Now I'm going to quickly make some changes to our config here, as well as to our main function and to our Docker Compose to make sure that everything is linked properly. The first thing I'm going to do with our config, I'm actually going to remove these parameters here. I'm going to make this a little bit simpler, and I'm just going to call this one here host. And we're going to use a cool feature from Pydantic. We're going to say from Pydantic, we're going to import base settings. And now if we inherit from base settings, then it's actually going to take this here from the environment. So it's going to look for the name host as an environment variable. So we don't even have to call this one anymore. And to have our typing here, well, now we could have this be a string, but Pydantic actually has an even nicer feature that we can use, which is going to be a Postgres DSN. And this will basically say that this needs to be some sort of Postgres connection string. Now we're going to have one extra option here. We're going to define some extra configs or overwrite those. And we're going to define the environment prefix to be db underscore. So what this means is that for every environment or for every value in here, we're going to be looking for the environment value, like this. But because we've defined an environment prefix, that basically says for every value here, the environment value will actually have this prefix associated to it. So it will look like this. And so that's kind of what we've set up here. And you can see it saves us a bit of space because now we don't have to call this os.getEnv every time. And we can even have this cleaner because we don't have to repeat this db underscore every single time. All right, so this is how we've updated our config. Because we are using our config here, I need to update this host that we're using, that we're creating our database connection to. And now the last thing, or the second last thing, is right now I'm just going to put this in our main function. I'm going to kind of do this a little bit haphazardly because we're actually going to change this out later on for a different library because SQL Alchemy does not allow asynchronous connections. But for now, we're just going to use all this to see how we can create tables and how we can perform migrations, which we'll look at in a following lesson. So for now, I'm just going to say from models, we're going to import recreate Postgres tables, and I'm just going to call recreate Postgres tables. And again, the reason I can import it directly from models here rather than going into models.base is because in our initialization file here, I've already imported it. So that kind of makes it available at this package level, which is why I'm able to import it directly like this. So essentially what we're doing here is before our, or when we're running this main function, before our application gets created, we're going to call this function here. All right, now we need to update our Docker Compose. So the first thing that we need to do is we need to provide some sort of environment variable, which is going to be our DB host, which is going to be our database connection string. So this value is going to, no quotation marks here, it's going to start with PostgreSQL, and it's important we use PostgreSQL and not Postgres because, well, SQL Alchemy is looking for PostgreSQL here, // and then we're going to have the username, the database username, the database password, the database like host address. So for example, like some url.com or whatever. So the host address here. Then we're going to have the port, which we're using the default one, 5432, and then we're going to have the database name. So looking down at the database that we've created here, and also into our environment variables here, our username is Postgres, our password is Postgres, and our database name is Postgres. So I'm going to fill those in. So our username here that we've created is Postgres, our password is also Postgres, and our database name is also Postgres. So what is our host address? Well, what's really nice about Docker Compose is that our host address is actually just going to be the name here that we've assigned to this service, like this. Now, obviously, when you're launching this in the cloud somewhere, you're actually going to use probably some like internal address, either probably not an IP address, but probably some sort of like name that gets resolved to some IP address somewhere. But for us in a Docker Compose setting, this is just going to be as simple as providing the name that we've given the service here. Now we're actually going to add one more thing here, because before our application even starts, we're saying create these Postgres tables. We need to ensure that this Postgres image here, or this Postgres container, is running before our application starts. So we're going to say this service depends on the Postgres DB. And so that way we're basically saying that for this to run properly, this thing needs to be running. All right, so we've gotten through a lot of stuff, but now we can finally, start everything and get everything running. So rather than using our make file, I'm just going to say docker compose up ---- build, which is going to rebuild everything. Now, the first time you run this is probably going to take a little bit of time because you actually need to do a lot of rebuilding because we've changed our pipenv here, and yeah, so it'll probably take a little bit of time. But if you do it more than once, then after that it's going to be cached and it should obviously go a little bit quicker. All right, so we're finally done building. Our containers are starting up. We can see our Postgres instance here. Our testing instance is currently complaining because we did not provide the host environment variable, which is fine. We're actually going to create a separate kind of testing Postgres container for it later. Let's see here. Oh, it complained. Right. We also need to make sure, because in our Docker Compose currently, we do not copy over the models. And I'm not going to put that in our Docker file. I'm not going to put that in our Docker file, but I am going to attach it as a volume. So I'm going to say models is going to map to models in here. And I'm going to take this down and start that up one more time to make sure that we actually also have this models taken over. And yeah, wait for that to build. It's going to be a lot quicker now because everything is cached. All right, Postgres is up and running. Our testing container is crashing, which is fine. And our main service, application service, is running. Excellent. And now, let's take a look here. So it's saying no column U is present. Let's quickly take a look. And actually, I think these need to be iterables instead. So let's try restarting this one more time. And oops, there we go. All right, so there we go. We got it running. Sorry, there are two different ways of creating our tables. Right now we've used the class version, which I actually prefer, but there's a different one where we can just define a table object where we have to use this C syntax. But in our case, for our classes, obviously it makes sense that we just access the value directly. But all right, so after 2 quick bug fixes, we now got it running. And let's go ahead and quickly scroll up here. And this output is, well, it's actually the output that we get because we have this echo equals true on. So it's telling us everything that it was doing. Obviously, you probably don't want to have this on in production. If you are using SQL Alchemy in production, we will actually be using a different engine for this because, again, SQL Alchemy does not support async, but we'll get to that later. And yeah, we can see here, the commands that it was running, creating the tables for us, for example. And I'm going to go ahead and open data grip, which is also what was closing in the background earlier on, so that we can actually take a look at these tables to see that it was properly created for us and make sure all of that is done proper. So let's quickly wait for this to open here. All right, so we still have our local table connection from last time, and let's refresh this because this should contain our 2 new tables now that we've obviously just created. So yeah, there we go. Now obviously we don't want this table to actually be here anymore, and so in general, for one, you don't want to be using like a shared database schema like this, or at least when you are doing it, make sure that there's like no conflicts. Of course, it's much more ideal to have your own schema. And generally, that's what you'll have in a service. You may have some shared stuff that you're using if you're using some sort of warehouse or whatever. But yeah, so we were able to create our tables using this syntax. Obviously, this is nice for now, but as things kind of evolve, like it's very unlikely that your schemas will be defined once and forever and will never ever change again. At some point, you probably need to change them. And at that point, it's not really nice to use this command anymore, because if you do this, then all your data is going to be lost. And so instead, what we'll be looking at later on is doing migrations where we can actually do incremental updates and we'll keep track of that whole revision history. But yeah, that's obviously a lesson for another day because we've covered a lot of stuff now, but now we were able to actually include and create database objects from our Python code. And in the following lessons, we'll also look at how we can actually integrate this into our program too, so that we can read and write to databases too. So yeah, great job on getting through this lesson. I know it was a lot. And obviously, if you need a breather, go ahead and take that. If you want to, review some of the syntax that we've covered and make sure that you understand properly the reason why we've created each of these things, then, obviously I'd encourage you to do that too, to make sure that you're following each step and, you know why we're doing each thing, and maybe even be able to recreate it by yourself. So now that we've learned how we can create database models in our code with SQL Alchemy, we're going to look at how we can do automatic revisions and upgrades to our database. So I'm going to quickly open up data grip here too, and just kind of look at the current state. And essentially, we want to be able to, have a continuous change in our database without having to use, for example, these methods here, or also using raw SQL like we did in our console when we were creating our test table. So with our database open here now, obviously the first thing that we probably want to do is at least have our database service running here. If we want to start a single service in Docker Compose, we can just write Docker Compose up and then the service name, PostgreSDB. I'm going to run this in the background so that we can actually continue to use our terminal for stuff. So let's go ahead and run that. Oh, looks like it's already running. That's great. So I'm just going to bring everything down and then start it back up, just so that we only have this one service running. So let's do that again. Here we go. Okay, so looking at the current state of our database, it should be just like we left it last time. So we have this extra table that we had from previous, as well as these 2 tables that were kind of created with our current command. So yeah, this is obviously so far not super ideal what we've done, because we definitely do not want to be using this, where is it here, this drop all, because that will, if we drop our table, all the data will be gone too, right? So we don't want that. We want to be able to make gradual changes to our database that are reproducible, just like everything else we've tried to make as reproducible as possible. And just as a quick aside, I'm also going to take this echo statement away because this will just print everything out, and sometimes that can be a little bit annoying. So I'm just going to take this away to essentially reduce the output that we have. All right, so to work on our regressions, we're going to use alembic for this, and we're going to do pipenv install alembic --dev. So we're going to install this as a dev dependency. So we'll go ahead and run this and wait for the installation process to finish. And while we're actually doing this, something else that I'm going to do is I'm going to move SQL Alchemy and this scopg to binary from packages, from our kind of production packages, instead into the dev packages, because I'm also going to remove it from here, because this is kind of just like a temporary thing that we put in just to kind of see it working. And obviously we don't actually want this to happen every single time our service starts, because then every time we have a new service spinning up or a service restarting, essentially our whole database will be cleared, which we obviously don't want. So this is just kind of, to show what is possible, but yeah, we'll take that out. So I'm going to do pip env uninstall, install, and we'll uninstall SQL Alchemy as well as scopg2 binary. And then I'm going to let this installation or this uninstall run. And then now in a second, we're going to install these as dev dependencies instead, because we still want to use them, but we don't want to have them be part of our, production service. And just going ahead and installing these as dev dependencies now and letting this run. All right, so if we refresh our pip file, just open that back up. Yeah, there we go. So everything is now in dev packages. Excellent. So coming back to our migrations, what I'm going to do is I'm going to now enter our virtual environment again. And I'm going to start, or I'm going to initialize Alembic in our module here, or in our package here. So we'll say alembic init, and then we're going to give the name of the folder that we want to assign it to. The default is just kind of to use this. So we're going to stick with that. And then we'll see here we have a new alembic folder created, as well as an alembic.ini file. So the first thing that we're going to do is go into here and scroll down a little bit and look for this SQL Alchemy URL. And right now this is just kind of some default placeholder, but this is going to be the location of the database that we want to perform migrations against. And I'm just going to put, or rather go into our Docker Compose here. I'm going to copy this with the one exception that we now need to change this Postgres DB instead to a localhost, because we won't be running this from inside of our containers, but rather we're going to be running this from outside. So the location here is just going to be our localhost, but obviously if you want to apply this to elsewhere, then you'll have a different address here. And our port is just going to stick with our default Postgres port. All right, so we've updated that file. The next thing that we want to go do is in our env.py here, we need to update our metadata. So a really cool thing about Alembic is that if we point it to this metadata object, which is contained within our base object here, it can actually try to auto-generate some of the migrations for us, which we'll see exactly what that means in a second. Now, it's not going to be perfect, and we will have to double-check this and make some updates to it, but it's already a good start because it can save us a good amount of legwork. So yeah, we're going to point this to our metadata. So what I'm going to do is say from models, we're going to import base, and our target metadata is going to be base.metadata. Now, we can't leave it like this, unfortunately, because currently Alembic is not like its own package, and so we actually need to point it to the right location of where it can find this models. So to do that, I'm just going to import sys, and we're just going to add this to our path so that it can actually, or we're going to add to our path our current directory here so that I can actually properly find models. So an easy way to do that is I'm just going to say sys.path.insert, and we're going to insert in the second position, so index 1, just our kind of current location where we're running this from. Now, this can get a lot more complicated and there are more things that you can do. For example, you can use like the file name and then get like the absolute directory name for that and then kind of going up one path. But we're not going to worry about this too much because just handling these environments and all these locations can be a little bit of a pain. And so we're just going to kind of make sure that we run it from our base directory here, and then everything should work. Because there are more complicated ways that you can set this up to always find the right path regardless of where you are. And you can find an example of that on Stack Overflow, for example. But obviously, we're not going to just do that because we want to keep it a little bit simple here. Yeah, just so that we can go ahead and do our stuff. But if you ever do find yourself in that situation, then the quickest thing will just be a quick Google. How can I find the path of the parent directory of this file? You'll probably get a really nice Stack Overflow answer that you can just take over and implement in your code, which will save you a lot of legwork in terms of research and everything. But yeah, we'll keep it simple, and we're just going to say just add the current place where we're running it from into our path, which will make it be able to see everything in this current directory where we're running it from. All right, so I'm just going to add a new line here to just add a little bit of spacing to make it a little bit more readable. All right, so yeah, this is kind of what we have right now. One thing, or two things. The first thing, because we've removed this from our kind of core dependencies, I'm going to just take this out here. The other thing is, if we look at our config, remember we have to provide some sort of DB host, and we're using this config object inside of our models here. So we want to make sure that when we actually, and we'll see how to do this in a second, create a migration, because we need this base object and we want to have these objects attached to it too, we want to make sure that the parameter that we need here is well defined, otherwise it's going to crash. So what we need to do is set that environment variable. So the easiest way, or not the easiest, but a nice way to do this is I'm just going to create a new env file, env migrations local. And here I'm going to export db host, and I'm going to set this just to be this value here. And so this is, again, just going to be the location of our Postgres instance, which is what we need here in our config. So now we're ready to use Alembic to help us create migrations. And essentially what Alembic is going to do is it's going to look at all the objects registered to the metadata, including what we've added here, and then it's going to compare that using this information that we've provided where our Postgres instance or a Postgres database is actually running, and it's going to compare the two states, and based on that it's going to try to come up with a migration suggestion so that we can get from the current state of the database to the state that we want, which kind of contains all the tables and objects that we've defined here. So let's quickly open up our data grip here, and to properly do this, I want to have our database in a clean state, ideally. So we want to start with an empty database. So I'm going to remove everything that is in here right now. Just drop this, and there we go. So now it's empty, exactly what we want. Okay, great. So now we can start creating a migration. And to do that, we're going to do Alembic, and then we're going to use revision. And now this is where it gets really cool. We have this flag that we can set auto-generate, and we'll see what that does in a second. And then we can add a message, and we should add a message to our migration. And I'll just say creating first tables. And let's go ahead and run this, and then we can see, oh, sorry, I need to make sure we read our environment variable here, because we set it, but we defined it in a file, but we never actually set it. So I'm going to read from our migrations local environment file here, which is just going to set this environment variable for us. And let's go ahead and run our migration one more time. All right. So now if we go into Alembic, this versions folder, which was previously empty, now has a file included in it. And we can see there are several things here. So we have a revision ID, we have a down revision, which currently has nothing pointed to it, but we'll see what that does in just a little bit. We'll have quite a couple of statements here, but generally we'll have an upgrade and a downgrade. And the most important thing is that the upgrade and downgrade should be kind of complementary. If I run the upgrade, I should be able to run the downgrade that essentially undoes everything that was done here. And so in this way, we should be able to keep our database in a consistent state by being able to essentially apply either upgrade or downgrade migrations. And from that, we can then change our database. So let's take a look at what was created here. And we can expand our import list just to see what was imported. But we have this create table operation, which creates a user table. And here it, whoops, did not mean to do that. Here it defines the list of columns that are attached to this. And also here it defines the unique constraint, which if we go to our user table is the one that we've defined here. And so this is what was really cool about this auto-generate flag is it essentially looked at everything that we had, it looked at the current state of the database, and it decided automatically what it needs to put here to try to get to what we have defined in our Python objects here. So yeah, you can take a look through this just to, just to see, started dragging around stuff here again, just to see like what is going on. But essentially it's creating all these columns that we've defined. Here you can see it's creating a foreign key constraint, mapping this user ID from the like post to the user.id table. We have a primary key defined here for our ID column, unique constraints, as well as an index. And in the down revision, we drop. So we can see here, we've first created the user, then the like posts. So we're now dropping it in the opposite order. Sorry, the index was last, so we drop the index first. Then we drop the table, the like post, and then we drop the users. So essentially here we go from the top down, and then when we do the reverse, we start from the bottom, and we essentially undo every operation that we've done here. So this is really great. But again, I would actually recommend double checking all of this because something that you'll notice is that this created at timestamp or this created at column here, we've defined default values for it here, but these actually did not get transferred over. So we're going to run it once without this, and then we're going to just so that we can see how we can apply the migrations. And then we're actually going to change this here to make sure that we have a default value attached to it. So once again, seeing our database is currently empty, we're going to, or it has a table now created from Alembic, which is a table you don't really want to edit, but this kind of keeps track of the current migration that we're on. So what we're going to do is we're going to say Alembic upgrade head. And what that's going to do is it's going to look at the current migration that we're on in here, and then it's just going to, from that migration, it's just going to keep applying migrations on top of it until it reaches the newest migration. So we're just going to go from wherever we are now all the way to the latest migration. And yeah, let's go ahead and hit enter. And we can see here that essentially it ran this migration. This is just a random kind of tag it created for us. And the message that we have creating first tables. And so now if we refresh our database, here we can see we have our two tables, our like posts, and our users here associated with it. But as we see, if we try to like just use this kind of data group functionality to insert something, we can see our ID here as a default value because it's a primary key that's incrementing, which it was actually able to detect for us, but our created at does not actually come with a default. So let's undo this migration. And the way that we can do that is we can say Alembic downgrade -1, which is just go back one step. Now, right now we only have one step, which is going to take us to the very beginning, but, and we'll see in a second, there are different ways that we can do this, but we can use this syntax here to go back one step. So we're going to hit enter, and here obviously it's very important that this is defined properly, otherwise we're not going to end up in the same state that we were previously. And this should work that we should be able to run upgrade, downgrade, upgrade, downgrade, upgrade, downgrade, and we should be able to end up at the exact same state that we started with. So refreshing this, our like post and our users should be gone again, which they are. All right, so let's fix this here and let's actually add a default. So the way that we can add this default is we want to add here a server default value. And although here, here we use this datetime.datetime.utc now, in our Leanback migration, this function is a little bit different. We're going to go into SQL Alchemy. Here we're going to access func, and then here we're going to use the now. And here we are actually calling it. So this is going to give the server default to, again, kind of use that current timestamp. And you probably guessed we have to do the exact same thing also here for our created at column. All right, so let's go ahead and run our migration again. So previously we used this head syntax, which is just taking it from the current state and running all the migrations. We can also instead supply the specific migration version that we want to go up to. So for example, if we want to go up to exactly this migration, we can also put this tag here, hit enter, and refresh. And if we look at our user table again, and I just hit enter here, and let me try refreshing this. So here, now we can see we have a default associated with the ID, as well as a default that comes with the created at. So I don't even need to supply these. For example, here I can put 1, and this is going to be text, so A and B. And this is actually also going to be a string, so we'll do A, and B. And then we're going to commit these changes, and now we can see the ID as well as the server default for the timestamp were automatically filled in for us. If we want to remove the row, we'll just kind of do it simple over our little program here. Just click the minus, hit submit, and take that away. All right, very nice. Okay, so this is kind of the first step. But obviously, we're not just going to have one migration. The whole point is that we can add more and more and more migrations on top of each other. And so something that you may have noticed at, like some later point is that, oh, actually I wanted our username to not be nullable. So right now it's nullable, but ideally I want it to not be nullable. And you don't want to change previous migrations. You kind of want to leave them as is. And so if you want to change something, instead what you're going to do is you're going to create a new migration. Now, one way that we could do this is if we go into our users here and we set the nullable value here to false, then we can try to do another revision. So we're going to say a Leanback revision, auto-generate -m, and then we're going to say set username to not nullable. And maybe we'll also do the same thing for this short description. Here we'll say nullable equals false, and then we can add the set nullable and short description to not nullable, and we hit enter, and now it's going to create a new migration here for us. Now in this case, it was able to detect these changes, but in some cases actually, there are certain changes that you may make where it won't detect them. So let's delete this migration file. Now, once you've committed migration files and you've applied them to a database, you do not want to delete them. But if you're developing locally, then it's totally okay to delete these. But just make sure that you do not delete migration files that have already been applied. So obviously, I'm going to delete this because we haven't done anything with it. And all the stuff that we're doing is local. So even everything that we have, we can still remove everything that was added new. But I'm going to delete this, and instead, we're going to take the approach that we're just going to pretend that a Leanback wasn't able to detect this using the auto-generate. So I'm not going to use the auto-generate flag here, but instead, let me close this notification, I'm just going to create a revision without the auto-generate, which is just going to create a blank revision for us. I'm just going to copy this message here again. Oops, now we have extra quotes. Let's take these away. All right, so this is going to create a blank revision for us, and now we're going to write this upgrade and downgrade statement ourselves. So the changes that we want to make is we want to alter our username as well as our short description columns here, and we want to set the nullable from true to false. So the way that we can do that is we can use this sa.alter column, oh no, sorry, op.alter column, and now we're going to provide the table name of the column that we want to change, and you can already see here my IDE is kind of suggesting the syntax. So the table name is going to be user, the column is going to be username, and what we're going to change is we're going to set nullable to false. And then I'm just going to copy this and do the same thing here for short description. And then I'm going to copy this, and I'm going to put in our downgrade. We're going to set these to true again, so that we kind of end up at the same state if we run upgrade and downgrade. So you have to be careful with copy pasting, obviously, because if you have copy paste mistakes, like you forget to edit the table name or whatever other things, that can obviously cause problems. But for now, it kind of worked out. So just be aware when copy pasting that there are copy paste errors that can come through that you may have just forgotten to edit. All right, so let's quickly take a look up here. We have a new revision. You can see this tag is the same as the one in the file name here, and it also specifies a down revision now. So what this means is that when we apply this revision, this here points to the previous revision, which is this. So if we run migrations up to here, to run this migration would have had to come previously. And essentially this kind of helps us keep order. It tells us if we want to go backwards, what happens previously, and it also kind of puts a chain into our migrations, and it defines the steps that happen. All right, so now let's go ahead and run this migration, and we're going to do a Alembic upgrade head, which is just going to take it from our current state and applying all the migrations until we reach our last migration. So let's go ahead and run this, and here we can see now it's running this migration. It's running from here to this, and we're setting the username and short description to not nullable. So let's refresh our database here just so that our viewer here also is kind of with the newest state. And I'm going to update. I'm going to open up this user table again, try to do an insert, and here we can already see kind of by the way that it's displaying it that these columns are not allowed to be null. But let's actually try this. Let's set our username to something not null and our long bio to something not null and try to submit this. Now we're going to get an error because our short description violates the not null constraint because it's null here. And now if we add a value here, now it's going to work properly. So yeah, this is how we can go about using Alembic for migrations. And now if we want to, so previously we talked about downgrading. If we want to go down, for example, 2 migrations, which will actually bring us to a blank state, we can do Alembic downgrade -2, hit enter, and we'll see in a second here, it's running the downgrade. So from this down to this, and then from this down to the blank state. And if we refresh, then we can see we have nothing here. If we want to go to the final state, obviously we know how to do that. We can do either Alembic upgrade head, or we can do this migration here. But let's say we want to go to like a partial state, which is this one. So we only want to apply this migration, or we want to apply up to this migration. That's going to create the new tables for us, but currently these columns are still nullable. And let's apply it all the way to the end. And then we'll look at how we can downgrade to a specific migration. So updating this, now we can, let's refresh this. And once this is done refreshing, we don't actually need to refresh this, like the migration will have already happened, but if we want to see these changes visually here, then refreshing is needed. So here we can see just by the way that DataCrypt displays this, these two are grayed out, which means visually these can't be null, so our migration was applied successfully. We can also see the current migration that we're at here. And now if we want to go down to a specific migration, so rather than using this -1, -2, we can also specify Alembic downgrade and then the migration that we want to downgrade to. So let's say we want to go to this revision here. We can say we want to downgrade to this one here, and it's just going to take the steps down until we are at that migration, which in this case will again mean that these two columns are not null. And yeah, oh, still not there. So let's try that again. Refresh. There we go. Okay, so this is migrations. As you can see, there's a lot of nice stuff to this. One more thing I'm quickly going to cover is how we can also add new columns. So right now we are at this migration here, and let's just pretend that's the current state of our database. Maybe let's add a new column too. So let's add a new column. I'll just call it test to our users. So we're going to do op.add column. We're going to specify the table we want to add it to, which is going to be a user. Now we need to define the column object. So that's going to be sqlalchemy.column. We're going to have some name, test. We're going to have some value, or the type. Let's say we're going to make it a string here. And yeah, let's just kind of leave that as is. So if we want to add new columns later on, we can do it like this. And then we also have to, put this at the top. Do a drop column here so that we're removing this. The syntax here is a little bit different. We just provide the table name and the column name. So let's go ahead and do Alembic upgrade head. And this is our user table before. And we can refresh this. And in a second, we should see our new test column here. And then we should be able, here it is, and we should be able to Alembic downgrade to the previous revision, and that will take that away again. And let's just wait for that to be applied. There we go. All right, so I'm going to comment these out because obviously we don't want these, but I'll leave them as in here for reference. And definitely there are some other things that we can do, most of which, or a lot of which you can see in this initial migration here, like creating an index, a unique constraint, but we can also add more constraints later on, but I'm not going to go through all the combinations. And if you ever do need to look up, like, oh, I want to add a unique constraint, you can either try with the auto generation of migrations, but alternatively also, just a quick Google and you'll find the exact syntax that you need now that you are a little bit more familiar with how this will look like. And yeah, I hope you appreciate Alembic and see that it's a really nice tool to use because your database state will very likely change with time, and the best way to do this is just using some sort of migration tool. Alembic is great, but there are also other tools, especially like in other languages, they may use other tools. But for Python, I've mainly seen Alembic used for these cases. And yeah, again, just once the migration has been applied to like production or even to the like development database, make sure that you do not delete old migrations, because then if changes need to be made, things are going to get really out of whack because things are missing. So do your tests locally, and then get your database state into the state that you want it locally. And once you submit those, and they get applied in development and production, do not delete old migrations. Just make sure you stay aware of that. But yeah, aside from that, obviously having these migrations is extremely, extremely useful, because it allows us to keep versions of our database and be able to go up to and down to specific versions based on where we want to be. And this allows us to maintain our database state and actually update it with time without actually losing our data. Because otherwise, what we previously did with the drop and create, obviously once we do drop, all the data in all of our tables is going to disappear. All right, so now that we've seen how we can create tables and everything, let's actually go ahead and integrate using databases into our code. And really what we're going to end up doing here is we're going to add a nice little client for us, a database client that we'll be able to integrate. But before we get to that, I just want to take some steps through SQL Alchemy and really show you what we can do with it. So yeah, first things first, though, make sure that you ran your Docker Compose so that at least your Postgres is running. But Mine is already running from last time. So I'm just going to open up my data group here, and I'm simply going to go to our users table here, and I'm going to just add a couple of rows so that we can actually do stuff with it. So I'm just going to, fill in 2 rows here, like this, and just insert these. All right, great. So now we have some data that, if we want to query something, it'd be nice to have some example data that we can actually, use against. So first things first, I want to make sure I source this environment file because we're going to just do some examples here over like an interactive Python session. And for this, we need to have the config properly loaded because we're going to load stuff here from base, which depends on the config that we have here. And so we need to make sure that our db_host is set, which we've set in here. So I'm just going to get our, or load our migration environment so that we have this environment variable set here. All right, so now I'm going to go into an interactive Python session here, and I'm just going to start importing some dependencies that we're actually going to use, which I'll show you in a second how we're going to use them. So first off, I'm just going to import our base as well as our engine here. I'm also going to import our user object, import user, this one that we've created here. And now I'm going to import some small things from SQL Alchemy that I'll show you how we can use in a second. So I'm going to say from SQL Alchemy, we're going to import select, and from SQL Alchemy .orm, we're going to import session. All right, so the first thing that we're going to do is we're going to use this session object because really we want some way to connect to our database. Now, there are multiple ways of doing this. The session is one convenient way, and that's the one that we're going to use. And so to create a session, we're going to assign it to a variable. We're going to call this session object, and we're going to bind it to our engine that we've imported from here, right here, which is already configured to look at the host that we've set here in our environment variables. So we're going to bind this session to the engine, and I'm going to set this extra property here, future, to be true. And this is just going to essentially allow us to make sure we use the new version of the SQL Alchemy API that's currently being developed. So that way, we're kind of future-proof, and this is already kind of being developed and is being supported. And so we just want to make sure that we use this newer version, which has some nice stuff that comes with it. So yeah, setting future equal to true here. So now we have this session object. And what the session object allows us to do is currently it's kind of in an empty state, but whenever we start doing stuff, be that querying the database, be that adding things to the database, it will manage that session for us, and then it will allow us to essentially, do stuff against our database. And it also does really nice things like, or we can use it to handle, for example, transactions so that, either everything gets pushed or if there's a mistake, everything gets rolled back automatically. And yeah, it's just going to be a really nice proxy for us to just easily allow querying against our database. All right, so yeah, this session object is something that we're going to use a lot here. Okay, so the next thing that we want to do is we want to write SQL statements, right? We want to be able to query our database, be that with inserts, be that with updates, be that with delete statements, be that with select statements. We want to be able to query that. Now, rather than just writing pure SQL, instead, what we're going to do is we're actually going to use our database objects, and we're going to use essentially what is called ORMs, which is object relational mappers. So we have these objects which are more Pythonic because we have these class objects with class attributes and stuff like that, and we can create Python objects and then we can use those to query. So for example, if we want to write a select statement, rather than writing something like select star from user, I think it's plural, right? Yeah, user. Actually, so we already have it here. Rather than writing select statements like this, what instead we're going to do is we're going to use our SQL Alchemy to help us write these select statements, but we're going to use them in a we're going to write them using Python code. And there are several advantages to this. One of them is that they also become very reproducible because we can write, smaller statements and we're able to add on to them. Other advantages are that it's going to be much easier for us to manipulate queries because actually SQL Alchemy will take care of translating all of this into a query. So for example, if we want to add more filters or something like that, it's going to be very difficult for us if we have an existing SQL statement to parse it and make sure we add the filters in the right locations, differentiate between having the first where statement, and if we want to chain on additional commands, we have to then use and statements. And so rather than having to deal with all of this formatting, especially when things get dynamic and sometimes we want to add something in and other times we don't, we're just going to use SQL Alchemy's API for this. And yeah, it's just going to make our life so much easier because it will take care of all the formatting and we're able to just write it using essentially, like Python code. Well, not essentially, just using Python code. So let me show you an example of this. We're going to create a statement, and this is kind of like the default way that you could save your statement, but you could also write like select statement to be a little bit more specific. And we're going to use this select function that we've imported here from SQL Alchemy, and we're going to pass in here our user object that we've created here and have imported. All right, so this is essentially how we're going to be writing our queries. And you can see here we're going to be using Python functions and objects to write our queries rather than writing plain text SQL. But obviously, this is just a query. We still have to execute it. And so for that, we're going to use our sessions. And what we're going to do is go into our session object here. I'm going to use this .execute statement. And now in here, we can put the query that we want to execute. So in this case, it's going to be this select statement that we've created just above here. And now we still have to specify essentially what we want returned. So there are several different options for us. One of them is, for example, we can only return the first row. So if I run this, we can see here now we have a response. And actually what we have here is a user object. So we can see here it's a models.user.user. So it's this object here, and it's actually in the form of a tuple. So in this case, when we're kind of querying like this, and I'll show you a different way to query in a second too, we're going to get these objects returned to us. But a nice thing that we can add here is just put .scalars, and this way we're just going to, sorry, there's supposed to be an S here, scalars, there we go. So this way we can, get it in a nicer form, but essentially still we're getting this sort of class object. And we can see that by, if we store this result in a variable, we can look at the ID, we can look at the created at, we can look at the username. So this is this first row that we've inserted here. And another way, so this is kind of getting the first result. If we want to get everything, then we can do it like this. So we can use instead all, like that. If we print out our results, now we have 2, because currently we have 2 objects or 2 entries in our database here. If we want to look at the second one or the last one, and here look at the username, then that is going to be our second row here. So yeah, with this, it's nice because we have our Python objects that we have defined here previously, and we're able to write these queries in a, well, in a programmatic way rather than using plain text, which is going to be very difficult for us to kind of manipulate. So yeah, and then with that, obviously, we've seen 2 different statements here. One of them is first, the other one is this all statement here, and this just kind of depends on how much data you want returned. Here we're going to be returning, just the first row. Here we're going to be returning everything. And sometimes you don't want to use just return everything because it could be too much data, but we're actually going to approach that in a different way. But yeah, just to show you one more way that we can kind of go through a more paginated, or not essentially paginated, but a more iterative approach is I'm going to load it like this, and then I can actually loop through our response that we have here. I'm going to say for item in response, for example, and then I'm just going to print the item, which is just going to give us the same thing that we've seen above. But if I look, for example, at the last item now, which is this username here, then obviously it's the second row that we have. So in this way, we actually don't have to load everything into the memory at the same time, but instead we can iterate over it. Yeah, so this is kind of the different ways that we can go, the kind of very, very basics of how we can use SQL Alchemy to help us with querying. But we're actually not really going to use this very much. We're going to either stick to this one or this one, and we'll see why in a little bit. But essentially, we want to keep our sessions as short as possible so that we don't have like long-running connections that can potentially be blocking other things, and that the database also needs to keep that state. Instead, we're going to be handling that differently on the API side. So yeah, this is how we can go about, the very, very basics of querying. But actually, let's make this a little bit more complex. So let's go back to our select statement that we've defined up here, wherever that is. There we go. So obviously, we want to do more than probably select. So a simple extra thing that we want to do maybe is filter. So let's filter and only take the row where the username is B. So to do that, we can access our user object, for example, and we can say user.username, this one here, is equal to B. And now if we select everything, then we can see here we're only getting one response as expected because only one object here has the username equal to B. And so you can probably see when these queries get more and more and more complex, it's so much nicer to write it in this sort of format and have SQL Alchemy take care of the formatting for us rather than us having to write all of this as plain text, queries. And obviously the other nice thing that we get is there's a lot of reusability because we can define smaller parts of the queries and then reuse them in different sections. So yeah, we just get a lot of benefits from using this ORM approach and using Python code to write SQL rather than having to actually just write it as plain text. So yeah, this is kind of one thing. The other thing that I do want to touch on is that it may not always be possible for you to have these objects in the same location. And so something that you can actually do is, obviously you can, define them in here too, but something that you may want to do is instead try to load them from the database. And so, yeah, if you don't have these available, you can actually go into your base metadata object like this, and here's a tables attribute, and here, for example, you can access the tables based on their table name. So it's going to be this table name here. So here we can also access this user table, and we can see here this is kind of what is associated with that. So with this, we can also get this user table again. And how do we write queries with this? So if we want to write the same select statement, we're going to use, again, our select function here. We're going to go into base.metadata, and then we're going to access our tables again. We're going to access the user table like this. And this is, again, just going to be that same select statement that essentially this. So if I execute this again, yep. Oh, no, sorry, that was the wrong statement. This is select statement like this. So, and here also we have to take away the scalars. So there we go. So now we're getting our responses, but actually one thing you'll notice is we're getting the responses in a different way because here we're not using the objects that we've created, but instead are just kind of getting the rows returned. So here, it's nice because we have the data, but obviously we would also like to know what columns we have, and an easy way to access that would be just taking one of the rows and looking at the keys, and here we can get all the keys. If we want to have them in a more easily accessible way, we can also map them all into a list. And so then we have each individual row, as well as the columns associated to each of these rows. And so this approach can also be nice, this approach here, because then you're not dependent on having all these tables defined here, which could be, if the database already exists and you essentially want to use it, then you may not have all of that defined here. And it may also not be good to like have everything there, because if the table changes, then every single time someone makes a change, you also have to make that change on your side. So obviously there are some nice benefits to having it on your side, but at the same time, if it's defined elsewhere, you don't want to maintain the same copy and have to make all the same changes that is made in that original repository. And so in those cases, you can still access those table objects by, going into this metadata object. Now there is one important thing here, which is if we want to have a where filter like we did before, so let's take our statement here. In this case, we can't just access the ID field, but instead we have to access .c.id. So this is going to allow us to access the ID column. So if we want to access any columns, we have to prefix this here with a .c. And here now we can add that same filter that we had. So let's execute this one more time. And, oh, the ID, that's not what it's supposed to be. It's supposed to be the username. All right, so let's run that one more time. And, okay, so we've actually gotten ourselves into a little bit of a weird pickle here. So let's see. Yeah, we have a running transaction that still needs to be aborted. So what happened is when we had our ID selection here, this essentially failed, and so now our database is kind of stuck in a transaction. I guess this would be a good way to kind of segment into that. But essentially what we need to do is we first need to roll back our current transaction. And now we can execute our statement again, and there we go. So it works. So yeah, kind of transitioning into this with that occurrence is if we want to protect ourselves against this, what we can instead do is use the session context manager. So we're going to say with session.begin, and what this is going to do is it's going to allow us or essentially everything in here is going to be in a transaction, and at the very end, if something fails, it's going to roll it back for us so that we don't reach this state. So if we try to execute just this one here again, then, oops, there's not supposed to be parentheses around here. Let's do that one more time, because this is already an object. And now we've again begun a transaction. So one more time. There we go. So in this way, we can now essentially start a transaction in here. So with this, we're going to start a transaction, we're going to execute our query, and if it fails, or if it succeeds, our transaction is always going to end so that we don't end up in this bad state. And to see that again, so what we did previously with our bad statement is we had the ID here, and then we tried to execute this like this, and now we're kind of stuck in a bad state. And so if we try to run something else, it's going to fail, saying that we're still in a existing transaction. And so until we roll that transaction back, we can't really do anything else. But if we would have used and let me use this ID here again, if we would have used this with session.begin, and then here execute this, which is going to fail. And now if we update our statement to instead select on the username and try this again with session.begin, so now it's going to work. So yeah, really what we can do with this really nice context manager is everything in here is going to be wrapped in a transaction, and it's going to automatically handle failure for us. So yeah, that was kind of the last part that we were going to get to, but good segment we got into there by accident. But generally when we want to do this, we want to do this within this transaction block so that if we do make mistakes and something does fail, it gets automatically rolled back for us and we're not stuck in some bad state. But yeah, this is kind of how we can approach querying data with SQL Alchemy. And next we're then going to look at actually creating this database client for us that is then going to allow us to integrate this into our code. All right, so now that we've seen this SQL Alchemy intro And since we were doing kind of an interactive Python console, I've taken the main things that we did and put them in this file here. It's also on the GitHub so that you have that to review. I'm going to take this away now though, and we're going to start working on integrating the database now into our application. Now the first thing that we're going to want to do is just to pipenv uninstall, and we want to uninstall our dev dependencies from SQL Alchemy and scopg2 binary, and instead install them as production like normal packages. So we're going to uninstall both of these, and we're going to install them instead as regular packages. And yeah, just go ahead and let this run. All right, so now that this is finished running, let's also go ahead and actually build our Docker images again, because we've now changed our dependencies here. So we just want to make sure that we rebuild our Docker images too. All right, so let's go ahead and actually create a database client that we can use within our application. So what I'm going to do is I'm going to create a new directory here that I'm going to call clients. I could also create a, let me create this init file. Did I? Oh, I think that's a comma. Hold on 1 second. I could also create a DB file in here, like we did for config, for example, where I can put all of that stuff. But actually, usually, you may have several clients that help you do different things. And so, to have I have that structure already, I'm just going to create a clients folder, because you could have something that helps you interact with databases. You could have something that helps you interact with like an external API, or with some external either like web service. And so all of these could be like helper clients that you could put in here. So yeah, for that, because that structure is like semi-common, happens kind of on the regular. Yeah, I'm just going to put this into this clients directory here. Okay, so here in the clients, I'm going to create a DB. And here we're actually going to define our database client class, which we can then use to help us do all of these database things. So the first thing I'm going to do is write, that initialization. And so what we need for this is we need our config object, because obviously the config holds our database connection string, so we need that. And we're going to say from app.config, we're going to import config. So this config is of type config. And something that we're going to do now is, and for this, I'm just going to assume that you don't have these models here, because obviously having them makes your life a lot easier, but I'm going to assume we don't have them. And we're just going to go through everything, assuming that the database is already created and the models are somewhere else, and that we're essentially going to be using our metadata information that we looked at kind of towards the end previously to do all of this stuff. So yeah, to do this then I'm going to provide an extra parameter here, which is going to define the list of tables that we're expecting. And I'm going to say, from typing import optional. And yeah, I'm just going to make this optional so that in the case we do have the table objects here, that we don't need to provide them. But obviously, we'll either have them or we don't. So this may not necessarily need to be optional, but I'm just going to keep it optional. So this is going to be an optional list of strings. Okay, so let's add the config as a property of our class. The next thing that we also want to do is we want to have an engine associated to our database. So we're going to need the create engine. So I'm going to say from SQL Alchemy, we're going to import create engine like this. And we're going to create our engine. We're going to use our config.host. That's going to be our URL that we need to use. And here I'm also just going to enable future, just like we did for the session, to make sure that everything is set up to, use that new API syntax that we're using. All right. Next up, we want to also assign a session object like we had previously. And so here again, we want to make sure we import the session from sqlalchemy.orm, orm import session. All right. So we're going to initialize a session here, and we're going to bind it to our engine. And also here, we're going to set future to true. All right, so in the case where we don't have our classes or our objects defined here, we also don't have this like base and the metadata that was associated with it, because what we've done here when we created everything is we've kind of, because we're inheriting from base, this is automatically going to be added into our metadata. But in the case where we don't have these, we need to pull all of this information from our database. But first off, we need that metadata object. So to get the metadata object, we're going to import that from sqlalchemy, and we're going to initialize the metadata, and this too is going to be dependent on our engine. All right, so now we have this metadata object, but we still need to get all that table information. And so the way that we can do that is we can access our metadata object, and we can call .reflect on it. And this is going to then get the current state of the database and kind of bring it over so that we have it inside of our metadata information. So with this, we will now have all of that information available. There's one important thing to know here, which is this will not, or in my experience, this does not run well, or essentially it fails, if one of the tables does, or if a table does not have a primary key, that one does not get transferred over. So just be aware of that. If for some reason some of the tables are missing, it's very, very likely that that table does not have a primary key defined. Something that I'm actually going to do is I'm going to put this into a separate kind of method that we're going to use. I'm just going to return none, and then we're actually going to call this method, just because I don't want to be, like calling raw methods of objects within our initialization, but rather I would have that kind of be an attribute of our client. And one of these things is going to be the setup, which is going to be this reflecting statement here. And then I'm going to call this inside of our initialization. So we're still going to be doing the same thing, but instead we're just going to make it a method of our class, because I don't want to be just, calling methods of objects that we've created here in our initialization, but rather have a nicer structure where we only use class attributes and our class methods. All right. So finally, one more thing that I want to do to avoid that we have to constantly do metadata.tables and then have here our table name. What I'm going to do is I'm going to actually dynamically set each of the tables that we want to have as an attribute of our class. And so the way that I'm going to do that is I'm going to create a new method here that I'm going to call set internal database tables. And this is going to actually take this tables object, and what we're going to do is we're going to say for table in tables, for table in tables. And now what we want to have here is essentially in the end, what I want to be able to do is if I've initialized my database client like this, and we pass in the information here, I want to be able to access our user table, for example, like this, rather than having to do metadata.tables user like that. And so the way that I can set attributes like this is we actually have a really nice method in Python that we can use called setAttribute. And here we're going to define first, you can already see the object that we're going to set this attribute for. So the object is the current instance of our class. Then the name that this attribute is going to have, that's going to be the name of the table, and the value that this attribute is going to have, that's going to be getting that table from our metadata. So what are we doing here? We have our database client, that's the object we're setting. The table here, if our tables looks like this, So the first table value is going to be users. So what this is essentially doing is we are setting table.users like this. So this value is going to be the name of this attribute equal to this. But rather than writing it like this, and obviously this would be, or I guess if we had it out here, it would be like this. But rather than writing this explicitly like this, which could get very long, and we can't actually reference this name inside, the way that we're going to do it instead is using this set attribute method, which is going to allow us to do this. So yeah, that's kind of why we're using that. Okay. All right. And then I want to say, if our tables are defined, I want to call this method and I want to pass in the tables. Now, the interesting thing here, this trigger does not trigger if tables is none or if the length of tables is 0. So just kind of as a quick aside here, if I actually go into here and I define something like this, oops. In Python, we have this notion of truthy. So there are certain times when something is true-ish or not true. So, for example, if this is none, or yeah, I guess we can start with this. If, then this is not going to trigger because this is not true. But if we have something like this, our object is defined, then should this trigger or not? Well, Python decides no, and the reason or the logic behind it is if the length of this object that we're passing is 0, it's still going to be false. This is only going to trigger true if there's actually an element in here. So, like this. And similar things apply for strings. If we have an empty string, then this is also not going to, not going to trigger. So just kind of as a quick aside, in Python we have these notions of truthy, and if we write if or if not, and then here we would have a true or false condition, this true or false does not just need to be a true or false, but it can also be none, which gets treated as a none. Or we have this truthy notion, which is if we have this base state for certain variables. So for strings, we've seen it to be the empty one. For lists, it's going to be the empty list. For dictionaries, it will be the empty dictionary. For integers, it will be 0, for example. If 0, and then if we print OK, also this is not going to get triggered. So there's kind of like this base value that we have for every data type in Python where these truth conditions actually evaluate to false. And otherwise, if they are set to any of these non-base values, then they will evaluate to true. So just kind of as a quick aside, this can be really useful because it makes things shorter, but obviously if you use it the wrong way, and then it cannot work properly. For example, if you want this to also be set on an empty table, then this is not going to get triggered. So yeah. All right, that aside, let's get back to it. So we have our initialization. Let's quickly go over what we're doing here again. We are passing in this config object, and we're just kind of keeping it with our database client because it's nice to have that config. We're creating an engine for our database that we're using the host from the config here. We're creating a session object based on this, or we're initializing a session based on the session object that we're binding to our engine like we've done previously. Both of these cases we set future to be true just so that we can use the new API. And we're also creating a metadata object and reflecting it because we're assuming here that we don't have these classes available, but rather we're using a database that's already been created and their classes are elsewhere. And so we're doing this so that we have this information available in like metadata.tables, because otherwise we won't have this information available. So we need to make sure that our metadata object gets properly updated, and then we're using this to set the internal attributes. So here we can say e.g. sets database client dot user equal to something like this, if user in tables. So just kind of as a quick reminder that this is what this does. which is just going to make our lives a little bit easier because then we don't always have to go into database client.metadata.tables and provide the name, but rather we can just access this as an attribute. And again, obviously this will depend on the list of tables that we provide here. So if there are more tables in the database, then we won't have all of these as attributes, only the ones that we provide here. All right, so this is kind of for the setup portion. Now I also want to have some helper methods for us that can take care of managing the transaction, even though it's a small thing, just because I don't want to have to repeat that code everywhere where we're using it, but rather we are going to define that once in our database client. It's going to take care of that for us, and outside we should not have to worry about dealing with all this database stuff. Our database client should be the thing responsible for that. We should be able to give it queries, and it should be able to take care of making sure our database gets queried properly and the database state is maintained and that we're not running into issues. That's the responsibility of our database client. So the first method that I'm going to define here is get first, which is just going to allow us to get the first object. Mostly we're going to be using this when we are just having a query where we expect one result. So we're going to do get first, and here we're going to provide a query, and we'll do the typing in a second, but what we're going to do is we're going to say with session, self.session.begin, and then we're going to do self.session.execute our query and store this result in here in our result object, and then we're just going to return this. So this is essentially what we did previously when we're going through our interactive Python console here, but we're starting a session, we're executing a query, we're getting the first result, and then we're just going to return it. So to add typing to this, our query here is going to be some sort of select block. So we're going to say from SQLalchemy.sql.expressions, we're going to import this select object, and that is going to be our type here. And what we're returning is actually a row. And to get that, and whoops, I'm putting this all over the place. We'll say here from SQLalchemy.engine, we're going to import row. So this is going to return a single row for us. And then the other option that I want to have is get all. Here we're going to pass a query, which is again going to be a select object. This is going to return a list of rows. And here we're going to do the same thing, but instead of calling first, we're going to call all. And one more thing here, if our object does not exist, we're actually going to return, this is going to return none. So I'm going to make this optional because this can actually return none. If our objects do not exist here, or if nothing is found, it's going to return an empty list, but if no object is found here, it's actually going to return none. So just to make sure we have that typing correct, I'm going to add that optional here. And then I'm going to add one more method for us that I'm going to call get paginated. And here we're going to provide our query again, but we're also going to provide a limit as well as an offset. And here we're also going to return a list of rows. And what we're going to do here is we're first going to modify our query. So let's say we have a whole select statement that says, for example, select everything from our users. Generally, if we have like hundreds of thousands or millions of users, like we don't want to get all that data. For one, it's going to not be nice to bring all of that into our database, into our application, and then send that all over a request. But rather, what we would do instead is we would query it, sequentially, like one step at a time. And so, for example, we can do this in steps of 5, and steps of 100, and steps of 1,000. But we want to chunk it up a little bit. And so what I'm going to do is I'm going to update our query, and I'm going to put a limit statement to it that's equal to our limit value here. And I'm also going to provide an offset. And this is going to allow us to write and create paginated endpoints where we can, the user of our API can say, okay, I want to get a paginated response of the users, and I want to get all the users, and what I'm going to do is I'm going to go through your paginated endpoint. I'm going to first get the first 200, then the next 200, then the next 200, then the next 200, and then the next 200, etc., 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 until they've read all the users. But they're going to be doing it piecewise so that we're not transferring essentially potentially boundless amounts of data that can get really large, and that's going to take forever to transfer. And also we need to load all of that, which can also cause problems if the amount of data that we're loading is too much, because our system may not actually have enough memory to load all of that into memory. So yeah, that's why we're going to have this get paginated here too. And then again, we're going to say, whoops, let that close in the background. Again, now we're going to execute our query, and we're going to do the same thing here as get all. And actually what we can do instead, if we want to, is we can just return self.getAll and pass our query here. So all that we're doing here is we're updating our query just a little bit, providing this like limit and offset, and then we're going to execute this query, and again it's just going to return a list of rows, but the size here is going to be limited because we're using this limit statement. All right, so for now this is going to kind of form the base of our database client, and it's going to allow us to replace our select statements that we have throughout the rest of our application, which is what we're going to look at next. And then we'll also look into updating and expanding our database client, and when needed, so that we can then also replace like the rest of our database usages that we have defined in our service here, so that we're finally moving away from using these dictionaries that are kind of database proxies for us to actually really using a database. All right, so now that we've finished the implementation of our database client here, let's go ahead and actually start replacing the operations that we're doing here instead with database connections. So the first thing that we need to do is we're going to start at the very top, and we're going to pass this in with our main function. So I'm going to say from app.clients.db, we're going to import our database client, and we also need our config. So we're going to say from app.config import config, because our database client depends on our config. So in our create application, I'm going to initialize our config now, because it has our database host connection credentials. And I'm also going to create our database client, which is going to be using our config here, and it also needs the tables. So the tables I'm just going to set for now to be user and liked host, like this. All right, so now I'm going to update, and essentially what I want to get to is, rather than using these things that we've created here, we instead just want to use database connections. So actually I'm going to remove this, I'm going to delete this, and I'm going to delete this here too. Okay, so now we have to update our create user router. So I'm going to go over here, and now we're no longer taking in these dictionaries, but instead we're taking in our database client, which is of type, if we go from app.clients.db, we're going to import our database client. So that is the type here. And we want to be able to use this in our user service, because here essentially is where we're going to be, instead of reading from our dictionaries and handling those dictionaries, we want to instead use the database. So here again, I want to provide this as an initialization. And again, we're going to say from app.clients.db, we're going to import a database client. Okay, there we go. And then we're going to set the database client as a property of our user service, like this. And I think I still need to pass that in here. Yep. Okay. Like this. So now we're starting up our application, and essentially we're creating our database client here, which depends on our config. We're passing it on to our routers. Our router creates the user service and passes the database client onto our user service. Now we have access to it here. Excellent. So now what we want to do is we want to update one of our methods here. We're going to start with the easiest one, which is going to be this get user info. So what we're going to do is, rather than using these dictionaries that we've defined here, we're instead going to use database connections. So what do we need? If we look at our object that we're creating here, we have the full user profile, which has the short description and long bio, as well as the username and the liked posts. This one is a little bit tricky. We'll get to this one in a second, or relatively compared to the other thing, but let's start with the basics, which is going to be getting the username, the short description, and the long bio. So if we go into our service here, we're going to construct our query, and we're going to say, we're going to use the select statement, which we need to import from SQL Alchemy. We're going to just import select. There we go. We're going to select from our user table, so self.databaseclient.user, which we now have access to because we've provided it as one of these properties here. So if this table exists, it will be in the attribute here. So we're going to just select from here, and because we are, filtering by a user ID, instead, going to say where self.databaseclient.column.id is equal to user ID. And I'm going to make this a little bit prettier and span it over several lines. We could just hit enter here and it'll kind of put this line break for us. But a nicer way of potentially doing this is putting this into parentheses like this. And then it's split up a little bit nicer for us. And we don't need those line breaks everywhere. Okay, so this is kind of our base query. It's not fully complete, as we'll see in a second, but here we will get everything except for our like posts. So now let's go ahead and also get this like post information. So to do that, we need to first join on our table, and we need to join, but what we need to do is, if we look at our database here, if we pull up our like post, we'd have a bunch of different user IDs liking a bunch of different posts. So we need to make sure we also filter here for the user. So what we're going to do is we're going to write a query that's going to get all the posts for the user, but we don't want them as individual rows. We want them as a list. So what we're going to do is we're going to aggregate them all into a single list, and then we're going to join that onto our database results. So to do that, we're going to say our liked posts query, and here we're going to select, and now we're going to select from the database, self.databaseclient.liked post. And what we want to do here is we want to, well, one thing that we want to do is, of course, we want to here filter by self.databaseclient.liked post, where the user ID is equal to the user ID provided. So first, we want to kind of get that row subset, but we don't want a bunch of rows. We want them all grouped together into one. And so what we're going to do in this case, and we just put parentheses around this too, so that we can have this be of a little bit nicer format. What we want to do in this case is we actually want to use the array ag function, which is going to take all the individual rows and kind of bring them together into an array. So I'm going to say from sqlalchemy.sql, I'm going to import func. And this is going to allow us access to SQL Alchemy aggregation, or to aggregation functions over SQL Alchemy. So rather than just selecting everything from the like post, first of all, we want to make sure we select the post ID, but actually what we want to do is we want to use this array ag function, which is going to take multiple of these rows and kind of bring them together into one row, and it's just going to be an array where each element is kind of, so like if we have 5 rows, we're going to bring them together into one row with an array that has 5 elements in it, which is what this is going to do for us. All right. So the other thing that we may also want to select is just going to be our user ID, so that we can use that for the join. So we're also going to select our user ID here. However, now that we're using these aggregation functions, we also need to make sure we have a group by statement, because this is obviously not an aggregation. This is just a single select. And so we want to make sure we properly group by so that this query is actually valid. So we're going to say dot group underscore by, and we're just going to group by this field here. All right. Okay, so this is going to be our like post query. To make this easy for us to use, we're going to make this be a CTE, and we're just going to give this a name. I'm just going to give this the same name, but it doesn't really matter. These don't have to be the same, but it can be if we want to. And we're just going to do that here because it's a little bit easier. Okay, so this is the subquery that we are selecting from. Again, we are filtering for the specific user ID in our like post here so that we only get this post that a single user liked. Then we're grouping by that user so that we can also select that user as an independent field, and we're using the array ag function to bring that all together into one row and have an array from that. So now what we need to do is join these results onto our user select statement so that we have these like posts in addition to all of our other user info. So here we're going to do .join. We're going to join it on here, or we're going to join it with this one here. And now we need to provide some join conditions. So I want to join on the user ID column from our like post query. I want that to join on the ID column of our user table. And I don't want an inner join here because that's going to be the default, but I'm going to say is outer true, which is actually going to make this a left outer join or a left join. So that way it's not an inner join, which will cause problems, but instead it's going to be an outer join. I'm just adding some formatting here to make it, again, a little bit nicer to read. And there we go. Not sure why I didn't auto-format that. Okay, excellent. So now we kind of have our base query. And now we can select our user. So we can say our user, and we're going to use our database client. Oops. And we're going to get first, and we're going to pass this query that we've constructed, which is going to create all of the user information for us. And now, rather than checking if user ID is not in this dictionary, we're just going to say if not user, because if this doesn't return any results, this is going to give us none. So we're going to say if not user, we're going to raise our 404. And now all we have to do is construct this user profile object here. So what I'm going to do is I'm going to create a user info here, and we know that if this is none, it's going to return or raise a 404 error. And if it's not none, I'm going to make this easy for myself. I'm going to convert this into a dictionary and then use the same keyword argument passing to create our pydantic object here. So I'm going to use, to get the column information, I can go into users.keys like this. And we also know our values, which is just in the user. And so a very quick and easy way to construct a dictionary from this is if we pass it into a dictionary like this, and we put it inside of this zip method, which is going to combine these together into one iterable. And I'll show you in the Python console what this exactly will do. So let's say we have our keys here, which is going to be A and B. Let's say we have our values, which is going to be 1 and 2. If we now do dict zip of keys and values, then it's going to take the first list here, or the first whatever iterable result this is, and these are going to be our keys of our dictionary, and the values, which is the second list, is going to be our values. So this is a really nice and easy way where we have two lists that we can combine into a dictionary. The first one here is going to be our keys, and the second ones here are going to be our values. We can see here each element maps. So the first element here maps to the first element here. So this is the key, this is the value, this is the key, this is the value. So this is just a really nice and easy way for us to move this into a dictionary. And now all I have to do is I can remove all of that, and I just have to provide this as input information into our full user profile. All right, woof. So let's go ahead and try this out, and hopefully everything works as expected. There are some things that we still need to change, which is we need to, well, one thing that we already need to update is not just selecting our user field here, but obviously we also want to select our liked posts that we're creating here. And so we need to access this column, and the easiest way to do that is to assign it a label so that it has a proper name. I'm going to call this liked posts, plural, the like posts of the user, and we're just going to access this column from the result of our liked post query. So what we're selecting is all the fields from the user table and the liked posts field from this query that we've created here that we're joining onto our table. All right, so make sure your Docker containers are running using the Docker compose commands that we have. Mine are already running. I haven't shut them down yet. And I'm going to pull up our documentation page here. And I'm going to have this user get statement here. And if we look at our database table, if we refresh this, we see here we have users 3 and 4. So I'm going to query for user 3, which should get us the user name 1. This is going to be an issue that we'll fix in a second. The short description B and the long bio C. So user ID 3 is who we're querying for. Let's run this. Okay, we got an error. I'm going to quickly pull up our Docker compose. Let's see. I think I forgot to, yeah, there we go. I forgot to put the C here to reference a column, a column of the table, because obviously our like post table does not have this attribute. It's a column that we want to access, so we have to do .c. Let's see, did I do that mistake anywhere else? Yeah, I think I did it here too. .c. I think I did it here too. And let's see. I think that should be it, but let's see. No, probably did it somewhere else too. Oh yeah. So here's the other thing. Because currently we don't actually have any like posts, and in our model here, we're not allowing this to be null. This has to have some value. So what I'm going to do is I'm going to add a like post value here, give it to our user ID 3, which is the one we're querying for, and let's just reference some random post ID 1 that we obviously don't have, but we're going to insert it anyway. So now we have something to actually use from here. And let's query that one more time. There we go. Excellent. So here are our results. We have almost everything. The only difference is we don't have the name. And the reason is because in our table, this is actually called the username. Now, obviously, one thing that we could do is we could update this alias here from name to username, but I don't want to go back and change our models. So what instead I'm going to do is I'm going to change our query. Rather than selecting everything from our user table, I'm going to select our short description. I hope I don't have a typo in here. I'm going to access our long bio, and I'm going to access the username, and I'm going to instead label it as name to make sure the label that we're using here is the one that we're also expecting in our full user profile. So because in our Docker Compose, we're kind of mapping everything over, and every time we make changes, because we've used this -- reload flag when we're starting, everything is restarting, so I don't need to restart my containers. So I could just hit execute again, and did I forget a C value somewhere? Let's take a look at our logs. Yep, I forgot the C values again. Again, we're accessing columns. And one more here. Okay, let's try that again. Okay, excellent. So now it works. We have the name A, which is for our user ID 3 here. Short description should be B, long bio should be C, which is what we have. The like post right now is just post ID 1, which is also what we have here. If we add another one like this, and we query, then now we see here we have 2. And also, if we add this for another user, say like this, then this shouldn't change because we're filtering for a user. Excellent. Okay, cool. So we've implemented a lot of logic here. And essentially what we were able to do is just use our statement here. And because of the way things are returned to us, it's a lot easier now. So I'm going to quickly close data grip because we don't need it for now anymore. And the last thing that we're going to do is essentially do the same thing now for our paginated results here. And to make my life easy, rather than having this massive query defined here, because we're going to reuse most of this, I'm going to cut this. I'm going to create a helper function for us. Let's call this get user info query. It's going to take a user ID as input, which is actually going to be optional. And it's going to return to us a select object. We need to make sure we import that from SQL Alchemy. Let's see, from SQL Alchemy dot SQL dot expressions. Yeah, select. Okay, it's just for typing. Okay, we want to make sure we return this query actually. And now the reason that I'm putting this optional is because in our paginated here, we're using like get all, essentially. We're going to get everything. And you can also see we're using this if we go into our routes under our here looking for all. So in this case, we're not going to provide a user ID. We don't have a user ID. So I want to make this optional. And now I'm just going to update our queries here. And I'm going to say, first of all, I need to close the parentheses here. If user ID, then we're going to update our query to, our query to also have this filter. And then we're going to make this a CTE at the end here so that we can easily use it. Okay. All right. And we're going to do the same thing down here. So we're only going to filter if the user ID is set. Then we're going to update our query to also have this filter. All right. So before we do this, we should probably double check that we didn't break anything, which we did. So let's see. Query is not defined. Oh yeah, so now that we have this, we need to go back into our get user info, and now we can just get the query using this function that we've created. So let's try that one more time. Okay, perfect, everything works as expected. Now we can use the same thing here, and I'm going to create our query, and it's going to get the user info. We're not going to provide a user ID. I'm going to provide also a default value to none for it here so that we don't need to set it if we don't want it. And then we're going to quickly take this over, but rather than doing get first, we're going to do get paginated. And now we need to provide the, let's see, is it going to give us the hint here? Yeah, no. So let's see, we need the limit and the offset. Okay. So our limit is our limit here, and the offset we've actually called start, which we should probably change to make sure all that is consistent, but we'll leave it as is for now. So these are going to be our users that we get from here. Okay, great. So now we just need to construct our user objects. So I'm going to create a list here called user infos. I'm going to say for user in users, and then I'm just going to create this user infos object using the same kind of dict creation that we did before. And I'm also going to create a full user profile object, and I'm just going to append this to our list here so that we're still returning this list of full user profiles, and we're just doing this for every single user that we get returned. So yeah, we can return these, and the other thing that we need is the total. And so to get the total, I'm going to just quickly here create a total query, and what we're going to do is we're going to select from the users self.databaseclient.user, and we want to count. So we just want to count the number of rows. So I'm going to use func.count the number of users here, and then I'm going to assign this a label. I'm going to call this total, and I'm going to again issue a query here, but rather than using the get paginated, I'm going to do get first. Now I can remove these parameters. The one thing to note here is if I do a get first and it's only one column being returned, we're actually going to have a tuple of 1 because we'll always have tuples returned here. So to get the actual integer value, I'm going to access the first value in our tuple. Oops, I deleted something that I shouldn't have. Oh yeah, there we go. Okay, and the query that we want to execute here is this total query. So we can remove all of this and let's test it out. Hopefully everything works, but if not, let's fix it. All right, so user all, I'm going to use our limit to 1 so that we should just get 1 response. And we get an error. Let's see what that error is. Okay, looks like I made a mistake probably in this select statement here. Right, I didn't specify the column, so I want to count, for example, the user ID column rather than, because this is just going to give us the table, so we can't count from the table, we want to count against a specific column. So let's try that one more time. Still an issue. Oh, user ID, oh yeah, doesn't have a user ID column, it's called ID. So one last time, third time's the charm. Excellent, there we go. So we can see our total is 2, which is what we expect because we have 2 entries. This is going to be our first entry because we're doing paginated. If we put in here 2, we should get 2 results. Okay, perfect. So yeah, we're getting close. We're starting to use our databases for everything, which is obviously a lot nicer. And now we can construct these queries, and then we can execute these queries against our database. And I'm just going to change this here to offset because that's the name that we're using. And yeah, hopefully you can see that using this sort of syntax is much nicer than if we had to like construct other queries just using string values. And that it's much nicer to construct queries like this, because here, for example, we can have additional conditional statements that we want to add if we want to add them. And yeah, it just makes our life so much easier. So yeah, we're getting close. We've implemented our get stuff. Now we still have some other things to do, like creating, deleting, and updating. But yeah, we'll get to those in the next lessons. All right, so now that we've learned how we can read from our database, let's also go ahead and now implement a insert statement. So previously we've had this create update user. What I'm going to do is I'm going to copy this and I'm going to separate them because the create and the update are actually going to be separate. So in this case, we're not going to provide a user ID because we're doing a creation. And we also don't need this, and we actually don't need any of this, but we will need to return the user ID. And I'm also going to go into our routes, and when we're doing a post, we are no longer doing create update, we're just doing create user. All right, so how can we insert users into our database? So what I'm going to do is, and actually just realized we don't need this anymore, so we'll take that away. First we need to, so we have the select object here that we can use, but we also want to use an insert. And we'll actually have a similar one available from SQL Alchemy. But we're not actually going to import the default one from here, but we're going to import the one specific to the Postgres dialect because it allows us to actually do a nice statement called onConflict do nothing, which we'll see in a little bit. So I'm going to say from SQL Alchemy .dialects.postgresql, I'm going to import insert. And then let's go down to our create user here. And now what we're going to do is really a very similar thing. We're going to create our query statement. So we're going to create some sort of insert statement. And here we're going to insert into our self.database_client.user table. And now we want to insert some stuff. So the syntax here is we're going to insert values like this, and now here we can provide a list of values that, or a mapping of values that we want to insert. And now all we have to do is just get those values that we want to insert. And so for me, the easiest way to do this, I think, is just going to be, let's create a dictionary and of all the values that we need, and then we can cast it in there. Obviously, we could also create like a pydantic model that, we can then essentially kind of convert that over. So we could create a separate model here that has just the username, the short description, and the long bio, which is what we need if we go to our user table. These are kind of like the base things that we need when inserting them here. So that's one way. Then we could pass that to a dictionary. I'm just going to keep it short for now, and I'm going to just use a dictionary. But again, you could also, where are our models now? Oh yeah, here, schemas, user. We could also do it like this, but in that case, we will then probably, well, maybe want to think about our structure here, because then we have like these repeat fields, and then we're just missing the like post. So, something to think about how we're using our objects here. So rather than refactoring everything and changing all that structure around, let's actually get to the implementation. And I'm going to create a dictionary that's going to contain our data. And here what we want is the username. We want the short description, and we also want the long bio. The nice thing is, from our full user profile, we have all of this information, so we can just access, whoops, did not mean to do that. We can just access here the username. Here we can just access, whoops, the short description. And here we can just access the long bio like this. And 1 second, messing myself up here with syntax. So these need to be strings. Okay, there we go. Okay, so we're creating our dictionary like this. Just as a quick side note, the syntax that I was going for is, rather than creating the dictionary like that, which we can do, is instead using this dict function, which will also create a dictionary in the similar way. And I'm actually going to stick with this one. I just think it's a little bit more readable. But yeah. Okay, so we have our data here. Now if we want to insert the values, we're going to provide a mapping of the values you want to set and the columns we want to set and the values you want to give to them. So I'm just going to unpack my dictionary into here. So now we have our insert statement. And now we can just again do self.databaseclient.get first. We can provide our insert statement here. And this will actually take care of the inserting for us. Let me quickly leave a note here. Alternatively, could create pydantic model, but will require some refactor of other models to keep things clean. Just as a note that, we can remember this. Okay, all right. So we've created our insert statement. However, we still need the user ID here. So obviously we can save our response like this, but this isn't really going to give us anything, because when we insert our values, the response that we're going to get is empty. But there's actually a nice statement that we can use, and I'm going to put these between parentheses so I can expand this over multiple lines, which is, if we do here dot returning, we can now define what values we want returned from what got inserted. So for example, if we say here we are returning the ID column from our user table, that means we're going to execute this statement here, and once this insert is executed, we're going to return the ID columns of the values that got inserted, which is really nice because that's exactly the information we need here for our user ID. So our user ID here is going to be, just because we're always going to be returning tuples, so it's just going to be the first element of our response, because we're getting first. So we're inserting one value, we're using the get first method that we've implemented, which is just going to execute that query, return the first value that was returned, and what's going to be returned to us, because usually an insert statement doesn't return anything, but here we've added a returning statement. And this is going to return to us the ID column, which means it's going to return to us the ID of the rows that got inserted, or in this case, the singular row that got inserted. And yeah, because this is always going to be returned as a tuple, but we're only returning one column, we're just going to access the first element in that tuple, which is going to give us that user ID. All right, so let's try that out. I'm going to refresh my documentation page here, go into posts, let's try it out. Let's give it a name here, like, oh, A, I think we already have that. Yeah, A we already have. So let's try something we don't have yet, because we'll see in a second what happens when we do. Let's go ahead and hit execute. And here it works. So we got user ID 5 returned to us. If we refresh our database, you can see here we have a new row inserted, short description, long bio, just string, which is kind of the default values that come here. All right, so nice, this is working. However, if I try to do this again, we're now going to get an internal server error. If we look at our Docker Compose logs, it's going to say we have a conflict because the username already exists. So we're breaking a unique constraint. So what we're going to do to fix this is we're going to update our insert statement, and we're going to say insert on conflict, on conflict do nothing. So, and for this to work, this is why we needed this PostgreSQL dialect insert. We have this on conflict do nothing, and here we can then define the index elements that we're checking the conflict for. So in this case, we want to check if there's a conflict on the username, and if there is a conflict on this, then instead of trying to insert, we're instead, as the name suggests, do nothing. There's another version of this called onConflict do update, but we're not going to implement this because we're going to have two separate versions, right? We're going to have our create, and we're going to have our update, which is going to be our put for us. So we're not going to use this here. We're going to do onConflict do nothing. So because we're trying to insert, if that user already exists, we're just not going to do anything. And that way, we don't fail. However, if we now try this, we're still going to get an internal server error because we're trying to get a user ID of someone who wasn't inserted. So now we should probably update our exception handling a little bit. And we're going to say if not res. So remember, if we don't get anything from here, it's going to give us a none response, which is going to be falsy. Now we want to raise an exception. I'm going to create a new exception here. I'm going to say user already exists, exception, pass. We're not going to define anything else for this. I'm going to add it to my exception handler and just do some proper formatting here. So I'm going to take this over. We're going to import this. We're going to add the exception handler for the user already exists exception. I'm not going to add any extra information right now because it's kind of going in a different direction. Tried to insert user that already exists. And the response that we're going to return is just a general 400 saying user already exists. And now we're going to go back to our service here, and we're going to raise this user already exists exception. But to do that, we also need to import it. So in the case where we have this onConflict do nothing, and we essentially get nothing returned, we're going to raise our custom exception, which we've added to our custom exception handler. So let's try that out. There we go. User already exists. Excellent. So now we have the ability to add new users into our database, as we can see here. So we can add them in, and if there are any conflicts, then we deal with them in a proper way, and our application doesn't fail. All right, so we've seen reading and inserting. Now let's go ahead and also work on updating. So I'm going to use our create update user here because technically our put can do both. So we're going to have our create update. However, if we look at our put routes here, it always provides a user ID. So going back to our service, this user ID is now no longer optional, but it's going to be required. And a lot of what we're going to do is actually what we have here. So I'm going to copy most of this over, but we're going to change things around just a little bit. So the first thing that we're going to change around is our data here. Actually, we already know the ID because it's provided on input. So we can add that in. We have our insert statement here. Now the thing is, with the put, we do want to overwrite. We don't want to do on conflict do nothing, but we want to do on conflict on, hold on, conflict do update. So this is what we want to do instead. So how can we formulate this on conflict do update? So that means whenever there is, well, some sort of conflict, like a unique constraint is, has an issue, or a, like a primary constraint has an issue, we want to do a certain update. So we can specify the constraint that we want to check for conflict. In this case, because we're providing the user ID, I want to check against the user's primary key. So this one here, and this constraint here, as we can see, is actually called user primary key here. So we want to make sure that if we have a conflict against the primary key, because we're providing a user ID, that we update the rows there. All right, so we're changing it from onConflict to update. Okay, so the next thing that we want to do is we want to define what values we want to set. And we can do this by using the set underscore parameter. And really what we want to set is everything here except for the ID. Although we technically could, but we don't need to overwrite it because it's going to stay the same. So yeah, this is kind of really all that we have to do for changing from the post to the put. I'm going to change things around a little bit though. I'm going to make this data no ID, and then I'm going to create our data to be everything from data no ID, as well as also provide this. And so that way we don't have to copy everything over and reuse it, but we can just reference this variable that we have up here. All right, so yeah, let's take a look at our database here. Make sure it's up to date, which it is. Excellent. So now let's try to update this user 5 here. And we're going to use our put, and instead we're going to overwrite the username, the short description, and a long bio. And this, well, we'll leave that in for now. So here, going to our put. So we're going to update the user with the ID 5. We're going to have here some name, some short description, some long bio. Now if we hit execute on this, okay, we get a null response. That's weird. We'll look into that in a second. So if we refresh our database here, so there we go. The information that we've inserted over here, and if we want to, we can, of course, insert a new row, like some other name, and insert that, and there we go. So that also still works. So now we can both update as well as insert. Let's take a look at why our user ID here is not returning. So let's take a look at our routes. Oh, okay, so we're just setting it to return as null. So we're going to return that user ID, and yeah, we're also returning just an integer. Okay, so let's update this one and make sure that we're getting proper values returned. Yeah, we are. But this doesn't look like we have in our insert. So we have the created user. So let's use this format here because that's nicer. And our response model here is going to be this one. So let's change this back to some other name. There we go, user ID 6, and if we refresh that, some other name. Excellent. Okay, nice. Yeah. So, oops, did not mean to do that. Just double clicking on this kind of brought that all back, but otherwise we can also go into the view and bring back our project file view here. But yeah, so this is how we can go about updating to. So we've seen that we can create here, but now for the put case, we can do both create as well as update. Now we have one more thing left here, which is if we go over here and we use an existing username, now we're going to get our internal server error again. So we can see here this is an SQL Alchemy integrity error. And so what we're going to do in this case is we're just going to, if we encounter this exception, we're going to specifically look for this, and we're just going to raise our own custom exception. So rather than having our application crash and give a 500 error, we want to catch this one and give a better error response about it. So I'm going to wrap this all into a try and accept block. We're going to try to do this, and actually something else, we don't even need to set our username here, and we also don't need this returning statement because we're already, the user ID, because we're already have this user ID here, right? So we don't need to return anything or get anything. Okay, so we're going to accept for this integrity error, which can be found, which we can see in our logs here too, in it was sql.exe.set integrity error. So we're going to say from sqlalchemy.exe, we're going to import this integrity error. And here we're going to accept for this integrity error. Whoops. And let's also just, well, actually, I guess because rather than raising our own exception, we already have this one from SQL Alchemy. So instead what we're going to do is we can just add this directly to our exception handling. We don't even need to create our own exception. So we're going to go into our exception handler, we can add another custom exception, and we're going to have this integrity error. We can say new, encountered integrity error when inserting user conflicts with existing user. So if we want to, we can be a little bit vague about it, to just say that there's been some problem, the user conflicts with the existing user. So if we try that one more time, there we go. We can see here our user conflicts with the existing user. And yeah, so we've just added this as an additional exception handler. If we encounter this integrity error, then we can say that there's some sort of conflict going on. As another quick aside, previously, and we're not using this right now, but I just wanted to let you know, because when we did our insert, we're only inserting a single row, but just so that you know, if you want to insert multiple, you can put this into a list. So you can just provide like a list of inputs here, like this. So this will also work just fine, so we can test that out too. Going back to what we previously had, let's try something out. Some more names, and oops, did not want that. Execute, refresh. So this still works. So we can see if we want to insert multiple, you can just provide this input as a list. And let me undo this, but provide this as a comment. So that, just so that you know. Okay, so yeah, we have our exception handling here, we have our logging, as well as our content here. As a final note, one more thing that you maybe want to do is actually log more details about the exception. So just to show you what we would log, we can, for example, return the string version of the exception that, there we go, my computer just froze. There we go. So if we try this out, here we can see we have a lot more details. It may not be super nice to return this because you can provide extra information that may or may not be necessary, and parsing this is also going to be difficult. for a consumer. So having maybe like a more general or at least a more formatted message will be nice. Um, but if we want to, we can actually, add this in here and also log our actual exception string so that if we are ever going through the logs, we actually know what the issue was. So generally for consumption, we can, give a more general or at least more readable message. But for logging, if we want to, we can have this so that if we need to go through the logs and see what's going on, then, it's going to be easier for us to debug rather than having some sort of vague message. All right, so the only thing missing for us now is this delete statement here. So yeah, let's go ahead and implement that. And from SQL Alchemy, we're going to import delete up here. And then in our delete user, we're again going to create a delete statement. We're going to delete against the user table, which is in self.databaseclient.user. And let's put this easily or nicely over multiple lines. We're going to filter where the user ID of the user table or the ID of the user table is equal to the user ID provided. Is equal to the user ID. Okay, so this is going to be our delete statement. Don't really need any of this because if the user doesn't exist, the user doesn't get deleted. And really nothing happens. So yeah, the only thing we need to change now is it would be good to have an extra method here where we can just execute without returning anything. So I'm going to do that. I'm going to create an extra helper that I'm going to call just execute. It's going to take a query, and this is actually going to be a delete object because that's the only one we're going to be using for now. And here we actually also want to take in an insert object because we are also, using this query for inserts. So I'm just going to import union here to make sure our typing is consistent still. So this one we're currently using for selects and insert. These ones only for selects. And this one is going to be for currently only for deletes. So we're taking a query and we're just going to do with, no, we have our query here. So we're just going to take this. We're not going to return anything. And we're also not going to get anything. So we're just going to execute the statement in a transaction. Or maybe we want to call that execute in transaction. Okay, so now we can do self.databaseclient.execute in transaction, our delete statement. There we go. So let's take a look at our database table. Let's try to delete user 10 here. Going to delete user ID 10. All right. Refresh. There we go. Excellent. If we try this again, nothing should happen because it's no longer there. Nothing is affected. We can also delete user 6, for example, if we want to. So yeah, there we go. Now we also have the deletion implemented. So this is nice. We have all of our stuff is now actually working with proper databases rather than the placeholders that we've previously issued for it. Which is obviously really nice because that's really how it should be working rather than having these internal dictionaries. All right, so we've come a great way implementing database usage into our application. However, currently everything is still synchronous. So if we go into our database client, for example, everything that we're doing here is synchronous operations. However, we're actually using an asynchronous application so we can make use of the great benefits that we get through async. So to implement async, we're actually going to use a separate library which is going to help us out a lot with this. And we're going to do, well, first of all, let's get out of our, not sure what's going on here. Deactivate. All right. Not sure why that looped around, but whatever. Went out of our virtual environment. I'm going to do pipenv install databases PostgreSQL. And I'm not sure why this is looping around, but I'll show you what I've typed in here. So pipenv install databases PostgreSQL like this. So this is what we want to install. This is going to be an asynchronous database client for us that we're going to use. And here we're going to make sure we install the required dependencies that we need because we're using a Postgres database connection. So we want to make sure that we have the correct drivers for that too. Yeah, so we're just going to let that install. And now that this is installed, we also want to make sure we rebuild our Docker image. So we're going to do make start build, or I'm just going to do make stop first to take anything down that's currently running. And then I'm going to do make start build. All right. Okay, and yeah, just make sure to let this run too, so that we're also rebuilding our Docker image. And here we go. We also have our extra dependency here too. All right, so now that we have everything installed, let's go ahead and actually update our application here to instead use our databases client. So we're going to start off with going here into our database client, and we're also going to say from databases, we're going to import database like this. We're going to create a new object here, self.database is equal to, we're going to initialize this database object, and here we're again going to provide the host parameter that we have defined in our config. All right, so in addition to this, we also actually need to start the connection for our database. Now, the thing is, because this is everything here is going to be asynchronous, we need to use coroutines. We need to put this in an asynchronous function definition. And so a really nice place to put this actually is, rather than doing this inside of our client somewhere, what we want to do is when our application starts up, we want to connect to the database, and when it shuts down, we want to stop that connection. And so something that we can actually do is if we go into our client here, and let's see, okay. So if we want to add in here this behavior, the way that we can do that is by, first of all, referencing our router. And now we can actually have this on event. And so here we can say on, when the event is startup, we can do specific things. So for example, we can define our startup event here to perform certain things. And one of those things may be to connect to our database. So what we want to do is we want to go into our database client, not self here, it's just our database client, database client, there we go, .database.connect. However, I don't want to access this attribute from outside, but rather it'd be nicer if we just had kind of helper methods here that, help us with this connection process, so that when we're accessing the attributes, we're kind of doing it internally. So we're just going to call connect here. We have to make this asynchronous because we're using await inside here. And now in our routes, we don't need to access the database attribute, but we can just call the connect method like we've defined it here. And then we're going to define another method called disconnect, which, as you probably guess, is going to do self.database.disconnect. And then we're going to implement also a shutdown behavior. So we're going to say user router on event shut down. And we're going to define this shutdown event. And what it's going to do is it's going to go into our database client, and we're going to call disconnect. So what this means is when our database application starts up, then we're going to call this connect method. And that is important because for us to use if we want to use our database client, it has to connect to the database. And so we have to call this connect method here. And then if our application is going down, we want to disconnect it so that we release that connection. And a really nice place to put this is on the startup and on the shutdown events. So again, when our application starts up, we connect. When it shuts down, we disconnect. All right, so we have our databases here. And now really what we want to do is every time where we use these session queries, we want to instead replace this with database queries. So let's go in here, and then we'll do this one by one. Now, fortunately, the syntax is going to be very similar, And what's amazing is we can actually even use these query objects that we've created from SQL Alchemy. So all that we really have to do is just replace these two lines in each of our statements here. Now we're going to start a transaction. In our session, we did session.begin. With databases, we're going to do an async with self.database.transaction. And this is going to, everything in this context here is now going to be executed as a transaction. And then we're going to say await self.database. And then if we do get first, here we want to do fetch 1. And we're going to provide our query here, store that in our response like this. And now we also want to make sure we make this function here asynchronous. And now I'm going to take this and just put this over here. For the all, instead of fetch 1, we're going to do fetch all. And for our execute, I'm going to take this. And instead of doing fetch all, we're just going to do execute. We have to remember to make these async. Here we don't care about the return value. And this here has to be async. And get all has to be async. And because this is async, we have to await this response here. And let's see, that should be everything that we needed to change to async. So async await, async await, async await, async await, async await. Okay, looks good. All right, so that was kind of like the bulk of the work that we had to do. Looks like there's a typo here, cute. Okay, and I probably need to change this. Actually, a nicer way to do this is right-click here, refactor, rename, and then it's going to make sure that it's updated in all the relevant places. So it's going to search through our files and just change that name wherever it's used. So we can see here it found another place where it's used. We're going to do the refactor, and it's going to do the renaming for us. Okay, so we can see also in our service here, properly renamed. All right, so now that we've updated the way that we're using our methods here, now we have to change everything here to instead use await statements. So here, for example, we need await, and I'm just going to search. Let's start at the bottom and then go work our way up. So we don't need it here because here we're just constructing the query. Here we are executing it. So to make sure we execute it, remember if it's a coroutine, we have to await it. So we're going to await that coroutine here. We've awaited this one already. We need to await this one. And we need to await this one. We need to await this one. We can't use indexing on our coroutine, so we're going to do total is equal to, and just access that value from here, since we can't do an index on a coroutine. So we have to execute the coroutine, get the response value, and then we're going to get that index. And also here, oh no, wait, this is just our query. Here we need to also do await. So I'm pretty sure this is everything. Let's see if there's anything else. Nope. So that looks pretty good. And all of these functions are already defined to be async, which is great because then we don't need to do any other changes there. All right. So the only other update that we need to make now is the response values that we get from our databases is a little bit different. We don't just, like when we're querying like this here, we no longer get like the values as tuples, but rather we get response objects. And actually, let's run this first real quick so that you can see what we're getting. So if we look at, if we just print this out, for example, and we run our get paginated query, and let's go ahead and open this up here, refresh my docs real quick. Let's try it out. So getting an internal server error. Generally, I like to use Docker Compose, but for some reason my application is not showing up here right now, so we'll just use the terminal, Docker PS, Docker logs here, and we can see, first of all, it's not a valid list, but that's because we can see here what we're getting returned are objects. And so all that we have to do is just extract the values like this, and in our other get here like this. And if we now try this out, there we go, this works properly. And our get, say, user ID 3, this one also works properly. And yeah, so nice. That is working pretty well. There are some other changes that we still have to do, unfortunately, because in our put, where we've used this create and update, the unfortunate thing is that these on-conflict statements are not getting carried over. So we're going to have to change this up just a little bit and yeah, make sure that we rewrite this using an update statement or an insert statement, depending on if the user ID exists or not. And let's go ahead and do that in the next lesson. All right, so let's go ahead and refactor our create update here to no longer use these on-conflict do updates, because unfortunately they don't work with our asynchronous database client, and instead just use the general update statement. So we're going to import update here, go to our create update user, and now we basically need to decide if we want to do a create, or if we want to do an insert, or if we want to do an update. So one easy way that we can do that is we can basically formulate a query, or we actually use our, where is it here? Get user info. And here, essentially, we want to do this. We want to look for a specific user. And we know that if the user here is none, then we have nothing returned. So I'm just going to take this for now, and I'm going to move this over here. And now we need to say, if not user, then we want to insert it. Otherwise, we want to do an update. And I'm actually going to just call these both statements so that we can use either one. But our insert here is going to use, well, the insert one that we've defined. Our update here is going to use an update on the table, which is going to be the user table. We're going to add a where clause that's going to say which rows we're going to update. It's going to be where the ID is equal to the user ID, and the values that we're going to set are still going to be these database no ID values. So these are the values that we're going to be updating. So let's take that away. We're going to be executing this statement here. Otherwise, we're going to be inserting this user like that. Okay, so let's pull up our application here and take a look at this. So let's see here. Let's create a user with the ID 15 and provide a name here, like some random string. All right, it's saying user already exists. Let's take a look at why. Oh, we don't have a returning statement like this. And because we're not returning anything, it says the user already exists because obviously we're not returning anything. All right, let's try that one more time with user ID 16 and add some other random string here. All right, so there we go. Let's also pull up data group here, load our table, and look into that. Okay, so there we go. We've got stuff that we've added. Yeah, okay, so we've done our updating, and now let's go ahead and go through everything just to make sure that everything's working properly. Obviously, doing this manually is good. It's good to confirm manually that things are working, but obviously we also want to put these things all into unit tests because we don't want to have to do this all the time. But it's good to, as you're developing, check things manually to make sure they're working as expected, and then you want to write tests for them too to make sure that those tests are going to be continuously run and that nothing changes, but also, maybe you missed something manually that you'll catch during a test. All right. So if I update this again, now we should be updating rather than inserting. So let's make sure that that's working too. So this is our latest state. And here it's telling us the user already exists, which is technically true. But maybe that's not a good error message to throw here anymore because, well, I mean, we don't need to throw it, right? Because, if the user does exist, then we're updating them. If they don't, we're inserting them. So it's not very useful. All right, so let's update this one more time. Okay, so there we go. We're returning the user ID either way, and we're updating them again. All right, so let's go through our list here. User all. I'm only going to do the first two because the other ones don't have like post described for them. So if I do more, we're going to break this. If we want to change this, we can go into our schemas and add an optional typing. Like this. And then it will work because these other users don't have posts defined for them. All right, so this is working. Let's try getting a specific user. Works. Put, we just tested. Let's delete user 16 here. Excellent. And everything should still be okay. Yep. And finally, also, let's create a new user. This. And yeah, there we go. And if we create this again with the same string, we should have that integrity error. User already exists. Okay, perfect. So yeah, with this, we were now able to migrate everything to instead use asynchronous database connections, which is really nice because we have that option for us in Fast API, and so it's really good that we're able to make use of it. Unfortunately, our function here got a little bit messy in the sense that we're reusing some of the stuff that we also have in our create user statement, so we can probably refactor this to make it cleaner, more repeatable and stuff like that. But we're not going to focus on this now because if we get into refactoring, we'll always be cleaning up extra stuff as we develop, which is obviously a good thing to do. But for now, this is still relatively short, and so we're just going to leave it like this. All right, so now that we've implemented all of this into our services, I want to show you also how we can update our unit tests to actually make use of this new functionality. So let's look at our Docker Compose here. Currently, we have our app, which has its own database, but our app test doesn't have a database to use. So we're going to create also an additional testing database that we can use specifically for testing. And it's not going to map to any outside port. It's also going to not reference any volume because whenever we take it down, we want that to reset anyway, because all of this should be, like fully reproducible whenever we're starting our tests. So we don't need to have any persistent data. And what we need to add here now is we need to make sure our testing database or our testing application depends on our testing database here. And we can also set the environment variable that this is going to be properly pointing to our testing database when we are setting our config. One more thing that I want to do too is update our entry point to rather than launching the application as it currently does, I just wanted to pause. And the way that we can do that is using this sleep command, and we're going to sleep for infinity. So rather than launching it with Uvicorn, we're just going to sleep because all we're going to be doing here anyway is running tests and stuff against it. So yeah, we're just going to overwrite our entry point here. So yeah, with that, we have our new testing database that doesn't have any persistent storage. It also doesn't have any outside port mapping. Our application here depends on the testing database. We have our environment variable set to make sure, to make sure we have the proper DB host configured here. So yeah, All right, excellent. Okay, then, oh, one more thing I want to do is I want to provide some app env that is just going to tell us if we are in test mode or not. So going into our client here, I'm going to change what we're doing here, and I'm going to say if os.get env app env equals testing or equals test, then we're going to do something here. Otherwise, we're just going to do as per normal. And so what we're going to do here is we're going to do here force rollback. So what this means is whenever we issue a transaction, afterwards we're going to just force everything to be back to its previous state. And this is important for us because obviously, we don't want states to transfer across our tests because that can mess with them. So we want to use this force rollback here. Yeah, to make sure that that's not transferring across our tests. And it auto did it for me, my IDE, but to get this to work, obviously we also need to import OS. All right, so for testing state, we're going into a force rollback to make sure that we don't have like states propagating. And let's go and take a look at our fixtures here. So we have our user service. Our user service has changed a little bit. It now needs a database client. So we're going to say from oops, no, we do need config, so we'll import that too. We're going to say from app.clients.db, we're going to import the database client. And then let's create a PyTest test fixture. The scope here is going to be session because it's just going to be our config. We'll have our testing config, and this is just going to return config like this. So it's just going to initialize our config. The next thing that we're going to have is going to be our database client. So we're going to do a pytest.fixture. And here we're also going to set the, actually no, we're going to keep our scope on a function. And we're going to have our testing DB client, which is going to be a database client. All right, and so here we're going to have our database client is equal to, we're going to initialize our database client. Let's look at the init parameters. We need the config and the tables. So our config is going to be our testing config here. And our tables are going to just be user and liked post. Now the thing is, because we have a fresh instance of our database, we actually need to create our tables. So what I'm going to do is we have this, where is it, models base here. We have this recreate Postgres table. So what I'm going to do is I'm going to say from models.user, I'm going to import user. From models.likePost, I'm going to import this one. And then from models.base, I'm going to import recreate Postgres tables. And actually, I think, do we do all this in our init? Yeah, if we move this down here, then we can actually just import that directly. So we're going to say from models, just import this. We just want to make sure that everything gets registered with our base. And then we're going to call here recreate Postgres table so that they're just going to be recreated for us here. All right. So now the next thing that we want to do is on startup and shutdown, usually we kind of do the connection, but now we have to do it ourselves here. So we're going to do database client dot connect, and then we're going to return the results. And after that, we want to database client dot disconnect. So rather than having a return statement here, which means we're never going to execute this part of the function, instead what we're going to do here is have a yield statement, which means as soon as we're done using this fixture, we're actually going to run the rest of the code. Now, because we're using asynchronous statements here, we need to define this as async, and we also want to make this a asynchronous fixture, so we're going to import pytest async.io, because this is here an asynchronous fixture. All right, so what we're doing is we're recreating our Postgres tables, recreating them. We have our database client here. We're connecting and we're yielding our database client, and then we're disconnecting so that the yield means once we're done using this, we're actually coming back into this fixture here, and our scope is a function scope. All right, so finally we have our user service here, which is going to depend, or is going to take this one here now as input. Okay, so now we have our user service here too, and now we can update our unit tests. We actually changed the functionality. You do not usually want to delete unit tests, but because we changed the functionality, we're actually going to take this away, and we're going to change this here to kind of make it work with what we have right now. So test delete works properly, and we have our user service here, and we also want a sample user profile like this. Okay, so the first thing that we want to do to make sure delete works properly is essentially we want to create it, right? So we're going to do user ID. We're going to use the create user method that we've created from our user service here to create a user. We're going to make sure that our user was created. So we're going to assert this is not null, not none. Then what we're going to do is we're going to issue a delete, and we need to use await here too because it's asynchronous. We're going to do await user service dot delete user. We're going to provide in here the user ID, and now to make sure that it's deleted, we're going to once again we're going to use a get. Sorry, we don't need an insert again. We're going to do a get. We're going to use our get user info and provide here the user ID. And the thing is, if you remember with this method, if our user is not found, it's raising a user not found exception. So we're going to look for this exception. All right, so we're inserting our user here, and actually this property here needs to be called name because that's what it's looking for when we were setting it. So yeah, just kind of being aware of that. We have the name, and yeah, we're creating the user. We're making sure that the user was created. We're deleting the user. We're trying to get the user, and if our user is not found, we're going to write as a user not found exception. And so this is going to test that the user was deleted properly. Obviously, we should probably be doing tests beforehand, like to make sure that our create user is working properly. And there we can actually use this and then write SQL statements ourselves to make sure, that we are selecting exactly what we want. So we could probably, if we wanted to test the create user, we would issue this statement, and then we would not use our get user info because that hasn't been tested, but instead we would just write a small select query where we just select filtering on that user ID, something like here, but a lot shorter, just to make sure that that user was actually inserted, and then we would just compare all of their properties, just as a kind of like a quick aside. But yeah, okay. So getting back to this is our test. And yeah, let's go ahead and run this. I'm just going to update this here to just focus on the unit tests right now, because we'll look at the integration tests in the next lesson. I'm going to do make stop and make start because I need to recreate our services here because, well, for one, we need to actually start our testing DB here. And for the other, we need to make sure that the proper environment variables are set for the hosting, stuff like that. So we just want to recreate our databases. We just want to recreate all of our services. Just as a quick aside, I've already had one of these testing databases running before, so if you have issues with make stop, just try a make start, which will also spin up the testing database, and then you can run a make stop in case it's saying that one of them can't be found, just kind of as a quick aside. But yeah, anyway, so now we're going to use our make unit tests to test against our testing container because that's where everything is set up. So we're going to do make unit tests. So you make unit tests. Okay. So let's go ahead and run this, and hopefully everything is running okay, and our tests are passing. Yeah, there we go. So one test passed, excellent, which is this test that we have here. All right, so yeah, this is how we can now update all of this. And actually, I think, to be honest, we probably don't even need this because, where is it? Here. Because we're executing this every single time, which means we're recreating all of our tables every single time. So we actually don't even need that in here because we're going to be running this every single time and yeah, recreating our tables every single time, which means nothing will be left over from test to test anyway, which also means that in our Docker Compose, we can remove this as an environment variable. And I think, oops, no, not here. We can also remove this import because we no longer need it. So yeah, that as a quick aside. And yeah, so that's kind of it for our unit tests. One thing that I am noticing now actually is because we're searching for session, the session is actually no longer needed because, well, we're not using the session for anything. So we can also take that out, can run our unit tests again to make sure that, well, things are working properly because we're actually using a good amount of what we have defined here. So yeah, I mean, obviously we want to write more unit tests, but this is the general idea, and it probably won't be very fun to watch me write out 10 unit tests for 10 different cases. However, it is a very good exercise for you to do. And obviously when we're writing production code, one unit test is not enough. We want to make sure we test every single part of our application, and we want to make sure that every single part works. So here, for example, we're assuming a lot of stuff works. We're assuming this works. But obviously we need to have separate tests to make sure that each of these is working as intended. But we run this method, and then we run a known piece of code that we know should work, where we actually rewrite the statement ourselves, kind of like I showed previously, like a very short version of what we're doing here, and then just getting that response and making sure that every single value that we have was inserted properly. So yeah. All right, so now let's also go ahead and take a look at how we can update our integration tests to make sure that these are properly working too. So obviously we're going to go into our make file and no longer just run our unit tests here. We're going to go into our integration conf tests here, and we need to make some changes. So one thing that we actually implemented is if we go into our routes, here we have startup and shutdown events. Now we need these to trigger so that we can connect to our database, so we have to handle that a little bit differently. In addition, we also need to make sure our database table gets created so that we don't run into any issues there. So let's start with creating the database table. We're going to say from models, we're going to import, recreate our Postgres tables. So we're going to initialize the application, and then let's go ahead and recreate these tables. This is something that we're going to move away in a second, and I'm going to rename this to base testing app. And we're going to only return the application here. You'll see why in a second, just so that we can keep this name in our test so that we don't have to rename a bunch of different stuff there. Now, the thing is, though, when we're importing from our main function here, we're actually also starting our application, which means it's going to kind of go through everything, and then it's going to try to also read the tables from a database that doesn't exist. So what I'm going to do is I'm just going to move these two steps into separate places. So I'm going to create a new file here. I'm going to call this app.py. We could also call it, maybe we should call it, let's rename this to create app.py. I'm going to take all of this from here, put it into create app, and from here we're then going to say from app.createApp, we're going to implement create application, and then over here, we're going to update this to now be from app.createApp so that we don't also start the application when going into our unit tests. Okay, so now going into our unit tests themselves here, to get these startup and shutdown events going, we actually need to use a testing client context. So I'm going to cut this and import this over here. And then we're going to say with test client, and we have our base testing app here as testing app. And again, the reason that I'm keeping this here now is so that we don't have to rename everything else down here. So I'm going to update all of the names in here like this and like this. And then I'm going to copy this context and just put everything in here in this context to make sure that it all happened, or that it's all obviously using our testing application. But using this context, we are then actually executing these startup and shutdown behaviors, which is what we need, because during the startup and shutdown, we actually do the database connection component. Okay, excellent. So up next, let's go ahead and take a look at our tests here. And something that we do want to do now, if we think about our conf tests, is we are no longer, this is a function scope, but maybe we can instead change this to be a session scope. And if we do have this as a session scope, then what we need to do now is, if we go into our database, the thing that we implemented previously but didn't end up using, but now we can use it, we can do if os.getEnv app env is equal to test, then we're going to do that thing we did before. Otherwise, we're going to stick with what we had now. We're going to import OS here. We're going to take this, and here we're going to do a force rollback and set that to true. Now in our Docker Compose, we need to make sure that we actually also define our app-env to be test in our testing container. Excellent. And yeah, so some more oddities kind of here. We have this thing called valid user ID because previously, we had like these base values that we had in our application, but we no longer have these. Another thing to also be aware of is that if we actually pull up our documentation here real quick, just as from one of the previous ones, we actually have to pass on the name value. And so to make sure we actually pass in these proper values, what I'm going to do is I'm going to just split this up, and I'm going to put this into our unit tests, because that's where we're using. Maybe I'll move this a little bit further up. And from here, we'll say from app.schemas.user, we're going to import the full user profile. And in our conf test here, we're going to use a similar thing, but it's just going to be a dictionary to make sure that our input is proper, because this is the input that we want to have, and we don't want to get this mapped to like a username value or something like that later. Okay, so we've updated all of that. Again, we have the valid user ID here, which really doesn't make much sense anymore for our context because there's nothing that's like preset. So once my application here unfreezes, let's actually just define the user ID here to be something. And then we can remove this. So let's update all of these cases, because this is actually no longer a valid user ID. This test case doesn't apply anymore because we actually don't raise a 404 if we delete a non-existent user, so we can remove this. That should be okay. Looks okay, or we'll look in a second. Here we're using the valid user ID, but yeah, actually, again, this is kind of using the previous assumption that data is already there. If no data is populated, then we also don't need this anymore. We still obviously need to test our get endpoints, but because we don't have any base data there, this doesn't make much sense because our database is supposed to be empty. Okay, and also here we don't need a valid user ID. but we can set a user ID here, and if we just do this get, then actually we're going to raise an exception because there's nothing in the database. So we also need to provide some sort of put here and actually insert something first, so that when we're running our get, we're not running into like 404 errors because the user is not found. All right, so we have our sample user profile here. And I think, oh yeah, of course, we need to update this. Okay. And if we delete a non-existent user, this test case again also, actually we don't even need this whole test case because we're already testing delete, at least in some form. Obviously we can do this better by putting, getting, and deleting, also like we did in our unit test, but at least we have something for now. All right, so let's try this out. Make unit. Actually, first we need to make stop and make start. Take down our Docker Compose and bring it back up because we've added a new environment variable here. So we want to make sure that we're passing that in too. So take everything down, bring it back up. And then we change this to only run our, to run all of our tests, not just our unit tests. So once this is done, let's go ahead and try that out. All right, so it looks like Docker had some sort of issue. I'm just going to take everything down, just repeat this, make stop and make start, and run that one more time. All right, there we go. Let's go ahead and make unit tests, and hopefully everything is passing. Otherwise, we'll fix those issues. All right, we've encountered an error. Let's take a look at what happened. OS has no attribute get env. Oh, looks like I made a typo here. All right, let's try that one more time. And let's take a look at our output here. Dict has no attribute dict. Ah, right, because we made this a dictionary instead. So we have to take away this dict casting. And here. And here. Let's check if there's anything else. Nope. All right, nice. And one more time. All right, there we go. Third time's the charm. So we do see some warnings here. Let's take a look at those. It's giving us something about depreciation, so things being deprecated, and we should actually update the way that we're referencing our values as well as our keys to use this mapping attribute. So let's go ahead and do that too, going into our service. And here. The warnings are not fail tests, but it's generally good to adhere to those. And let's try that one more time, and our warnings should go away now. Our tests are already passing, which is great, but our warnings should go away now too. All right, excellent. So yeah, there we go. Now we've implemented our asynchronous integration test tier 2, or we've had the asynchronous integration test. We've implemented the integration test to now also use the new database connections that we've implemented in this whole module. And since we're also on the topic of warnings, let's go ahead and get rid of this warning too, which has been here for quite a while. So it's asking us to make async IO mode strict or auto because what we're currently using is being deprecated. So we're going to add this async IO mode equals strict flag here. And let's run that one more time. Now hopefully this warning should also go away. All right, excellent. All passing tests and no warnings. So yeah, as a final note, just generally here again, you want to write more unit tests. You want to test different cases of like inserting and deleting and inserting reading and deleting reading just to make sure all of that is working properly. But yeah, again, more unit tests are probably not going to be very fun to watch me implement, but generally, when you're writing production systems, you want to make sure like everything is covered, but not only that all your code is covered and executed, but also just thinking about different edge cases that you may encounter and really testing the functionality of your application. Obviously, you don't need to repeat the same test multiple times. You don't need to retest the same functionality, but you can test it from different perspectives if you think one of those perspectives could potentially be an issue.